Hey everyone, welcome to my channel. You're watching Learn Tech with Sandeep Das, and in this session today, we're going to learn about day 3 Advanced GoLang Constructs, where we'll cover in very details about arrays, slices, maps, pointers, structs, interfaces, and error handling. And the end, we will just certainly understand the concurrency basics using GoRoutine and channel. Okay, I'll try to make it very interesting. Stay till the end and follow what I'm doing. Let's get started with arrays. Now, what exactly is array? Now, array in Go is a numbered sequence of elements of specified length and type. Okay. Now, note the point: specified length and type. Okay. So when you're defining an array in Go, you have to specify exactly how many number of the elements are going to be there and what is the data type of the array it is. Okay. And I'll show you a different ways to declare array. But before that, what are the characteristics of array? Let's go through that. First characteristics is the fixed type, as just say a few minutes back. So once declared, the size of an array cannot be changed. So array are the fixed number size. Okay. Now the value type. Array in Go are the value types. That means it is not reference type. So when you assign or pass an array to a new variable, or maybe pass the value to a function, that just pass the value and not the variable reference. What is the difference? I'll show practically, don't worry. Now third point is the zero value. So uninitialized elements of an array are set to zero value of that particular array type, and that also I will show you, don't worry. Now let me show you what are the different ways you can declare an array in Go. So very first, declaration without initialization, where you just say var, then the variable name, and then the fixed number size, that is 5 integer for example here, and the data type is integer. The second way is the declaration with initialization. So while declaring an array, we are assigning the value also with it. Okay. For example here var, then array, then in the third bracket we are saying 5, which is the number of elements it can hold, then integers equals to, and again the number of element can hold 5, then integer, and then in the second bracket we are giving the same number of elements like 1 2 3 4 5. Okay, this is how we're assigning value while declaring itself. Then with the shorthand, for example here you can see the third number example where I'm saying array, then the shorthand equals, then giving the number of the array size, then the data type which is integer, then giving the actual value, that is 1 2 3 4 5. Then the fourth example where initializing with specific elements, for example array, then equal shorthand equals, then the third bracket is 5, which is the number of element 5, then int, which is the data type, then you are saying 1, then again it's not comma, 1, then colon, then 10, then comma, then 3, then colon 30. What that means? So this initializes an array of 5 integers where the second element, or which is the index 1, because you know in any programming language the array starts with 0. Okay, so that means the second element which index is 1 is the value is set as 10, because that we have mentioned here, and the fourth element which index is 3, the value is set as 30, and all other elements value are set to 0. Now if an array where the most elements are start to their 0 values, it's called sparse array in Go. Okay, then the fifth way, which is using the 3 dot operator to infer the length. Okay, what is the example here? First, then say array, then shorthand equals, then you see in the third brackets we are giving 3 dots. Okay, which means that you don't have to immediately give the number of elements there will be. You put the elements, the values, then the array will automatically identify how many elements we have, and this is the fixed size element while defining it. Okay, now for example here the length of an array is inferred from the number of initializer elements. So we have 1 2 3 4 5, there is 5 element, so it will automatically become a fixed size array of 5. Okay, then the sixth way is array of array, or we call it multi-dimensional array. And how we define it? We say the var, the keyword, then the variable name which is multivar, and then we say the how many element will be there. We say 2 elements, so 2 array. Inside that 2 array, how many arrays will be there? We are saying there will be 3 values. Okay, that's why 2 then 3, so 2 arrays with each array containing 3 values. Okay, now this declares a 2-dimensional array, which is an array. So this multi, for example, as I say, this multi ARR array has the two arrays, each contains the three integer values. Okay. Then the sixth way, which is same multi-dimensional array, we are, while even defining the array variable, we are assigning the value as well. For example, multi-array, then shorthand equals, then you are saying in the third brackets 2 and in another third brackets 3, then int, which is the data type, and then the values, that is in the first array we have 1 2 3, in the second array we have 4 5 6. Okay, now this initializes two-dimensional array with specific values, you know that. Now the eighth one, which is array with pointers. Okay, and how we define the array with pointers or array pointers? We say var, the word keyword, then the variable name, for example ARR, then in the third brackets we say how many numbers of variable will be there, which you are creating pointer for, 5, and importantly that star int, and by the star only we can say this declares an array of pointers to integers. Okay, this is important. Then the ninth, that is array of structs. Okay, and how we define array of struct? First we define struct, say type, person, and struct, and in struct we say like what are the fields we have, name field and age field. Then if you want to create an array of this person, how we do it? We say var, the word keyword, then the name of the variable, which is person, and this person, how we can call it variable? In the third brackets we are saying fixed number 2, and then after that as a data type we are saying the data type is person, which is person is what? The struct, custom data type, right? So this is how we can create array of struct or custom data types. Now let me practically show you how can you declare array in different ways in the code, and all the codes that I'm going to show you will be in our official repo. You can just go to this official repo, and in the day 3 folder, just like in day 2 folder you have all the day 2 code examples, in similar way in day 3 you will have all the day 3 codes. Okay, now let's jump back to the code and show you then how different way you can declare array. First way, of course, as I discussed, the array, the word keyword, then the variable name, which is the array 1, then how many items should be in this particular array, then this 5, and what will be the data type of this each items, that is integer. Okay, then in the second, declaration with initialization, where we are again just giving the word keyword to declare this particular variable as an array. We are saying how many item will be there, and the data type again how many item and the data type of each item, and we are saying 1 2 3 4 5 all are integer values. Then using shorthand, so you don't actually need to specify every time the word keyword. You can just say the particular variable name, then shorthand. Okay, that is the colon equals, then the number of items that will be present in the array, which is 5 items. We are saying 5. Then the data type of each individual item, that is integer int, then the actual values, which is 1 2 3 4 5. Okay, then the fourth way, initialization with specific element. So we are saying for only the second element, that is the index 1, and only for the fourth element, that is the index 3, we want a specific value. So 10 and 3, all other items will be 0 by default. Okay, because this is integer. Okay, then the fifth one, which is using the triple dot operator, which is called infer length. So for example, here you are specifying the length 5 6, whatever you want to specify, right? But you can skip that. Okay, I mean it is behind the scene get calculated by Go, but you can skip giving the exact number. Instead you just specify how many items that you want to specify, like how many items you want to have in this particular array, and Go will automatically calculate and give the number to this. Okay, if it's find that you have given the 3 dots, we call it infer length. Okay, then the sixth one was the multi-dimensional arrays, right? Which is var, then the variable name here, then 2 arrays with 3 items each. Okay, after defining the multi-dimensional array, in because it's 2 array of array, right? So in the first array or first index array, we are seeing that the type is what? Because it's 3 integer, right? Or 3 items we can hold, right? So 3, and then you're giving the values. Similar way, the second element can also hold the 3 number of elements, right? So 3, then int, the data type is integer anyway we declared here. Then you are giving the values, right? And it's multi-dimensional array. The seventh one was the defining multi-dimensional array with the values itself. So 2, 3, exact same thing, but while defining the array, we are giving all the values also. So 7, 8, 9 and 10, 11, 12. Okay. Now the eighth example, which is the pointers array. Now pointers is what? It holds the memory addresses, right? So var, then the variable, that is pointers array. In array, we need fixed number size, right? So 3 element can be there. Then in the how we're going to say it is a pointer, right? This particular symbol star, using that you can tell this is a pointer. Pointer of what? Pointer of integer. Okay, so this pointer array hold the values will hold the memory addresses of integers. Now to show the actual example, we are defining 3 variables. Okay, num1, num2, num3, and all are integer values. Okay, so see 13, 14, 15. Now in the pointer array 0, first element, that is a 0 index, we are saying and num. If you use the and then the variable, so it's fetching the memory address of num1. Okay, similarly pointer array, then the second element, which is the index 1, that's using and. So again and to fetch the memory address of what? num2. And same thing in the pointer array 2 is fetching the memory address of num3. And you are storing in this pointer array the memory references or pointer of integers only. Okay. Now, if you want to print all these pointers, how it will happen? When you run the code, you will see it. Then the ninth example was array of structs. Okay. Now, first, let's define the custom structure again. This struct pointers, you're going to go very deep dives. Don't worry, we're going to simplify it all. So now, just for the sake of example, this is the kind of custom data type, which is type, then person, then the struct. Then in this custom data type person, we have 2 fields, name field and age field. Name is what? String, and age is what? Integer. Now we want to create array of this custom fields, okay, or custom data types. So how can you define it? Var struct, the name of the variable, that is, or name of the array, which is a struct array. Then how many, in this particular array, how many elements we can hold? We can hold 2 elements. And what will be the data type of the particular array, which is the person. Okay, and person is what? Person is a custom data type or a struct. Okay, then in the struct array 0, the first element we are giving, say, person, the struct, then the values Alice and 30. In the second element, which is the index 1, we are giving person, then the name as Bob, and the age as 25. Okay, so and then we are printing it. Now let me quickly run it so that I can show you the values, what it prints, and it will make things more clear that way. So go run, then this particular file, array declaration, and you will see. First, go one by one. For one, when you declare the array, but we didn't assign the values, there all values become what? 0. So if you declare an array and of element 1, 2, 100, any element, okay, you declare an array, and if you don't assign any values, by default all the values become 0 values. In the last session I explained what is 0 values, which is the default value of any data type. Okay, now the second one, which is the array of 5 integers, that is the declaration with initialization. So we given the value and the values came. In the third one, what we did, we say shorten declares. Again, the value are assigning and it will just print as it is. Then in the fourth one, we initialize a specific one. Again, what specific elements? For index 1, which is the second element, and index 3, which is the fourth element, we assign the values. And if you see, array initialization with specific elements, for the second element is 10, and the third element, which is the fourth item, the value is 30. Okay, and all other items become 0. Okay, then the fifth one, which is using the infer operator, that is the 3 dots. There we didn't mention the exact number of elements, but it will automatically back calculate it from the number of elements that is supplied as the initial value. okay, which is 1, 2, 3, 4, 5, and using that it is printed, right? The sixth is the multi-dimensional array, and you can see the values here. So first multi-dimensional array, the value when like we defined it and later assign the values. So the 1, 2, 3, 4, 5, 6, you can see two array with first array item is the 1, 2, 3, and the second array item value is the 4, 5, 6. Then the seventh, we define the multi-dimensional array and we assign the values as well, okay, all together using a shorthand, okay. And what are the values there? 7, 8, 9, the first element, and the 10, 12, 10, 11, 12 is the second element of array, okay. Now this is arrays of arrays. Now you understand that very clearly, right? Now the eighth example, the pointed array. So this pointer don't hold the exact value, but the memory reference or the pointer value, okay. So we just made a loop, and see, while printing, if we just remove this star, you know what will happen? It will just see print the memory addresses, okay. This all printed the memory addresses of the all this say num1, num2, num1, num2, and num3. Now if you want to fetch the, instead of the memory reference value, which is like looks like this, we want the actual values. How can you do it? We use the star here, okay. So then now run it, you see it printed the actual value. So this is how we can store the pointer array, okay, also pointers values in arrays, okay. Then the ninth one was array of struct. So struct means custom data type, right? Or say we're grouping the different or we're grouping multiple fields into a single name. This is what it is, and again we'll discuss a lot more after a few slides, okay. So so this is where we are defining a custom data type, and we are saying how many data we want. We want two array, also two items array. So we given in 2, then the name of this is struct array, and we given the values also here in the first element and the second element, and we have simply shown array of struct, and see the value printed. The first item was Alice 30, which is the name is Alice and the age is 30, and the second element value is Bob 25, which is the name is Bob and the value is 25. So this is how we can declare array in different ways, and this is how can we use also. Now that we have learned what are the different ways we can declare array, it is time to learn about the different common operation with array. And what exactly I'm talking about this common operation of array, I have covered total 5 use cases. There are many. As we move toward the course, we'll learn about more, but 5 common operation I will say about arrays are: first, checking the length of an array, and using this length. Okay, one note here. Like in other programming languages with different variables or say array, or maybe the different type of variables, for example maps and all that, you get some inbuilt function. But in Go, you don't have inbuilt function attached with those data types, okay, or the variables. You need external functions, built-in functions, but external functions, not comes with the variable itself, okay. For example, checking the length of an array, you have to use len, and the first bracket, that function, okay. For example, if you see there that the first one, to check to get the number of elements in an array, you have to use the built-in len function. For example, you have var my array, the variable name, then the type, which is we're saying element is 5 elements. So in third brackets we are saying 5, just 5 number element should be present, and int, and it is all the element will be integers, and if we don't mention any values, then it become all these elements become what, 0 values, right? Now if we check the length of this particular array, we will see say len, then shorten equals, then len the function, then inside the first brackets we have to mention the, or to pass the particular variable, okay. So just my array here, and it will get the value of that, it will return the value of particular length, okay. I will show you practically in a few minutes. Now how to copy an array. Now to copy an array, it's very simple. Just first you have, for example, you have one array already present, just define another array. Say for example here I have named it copy array equals to whatever array you had, it will just copy it, okay. Then modifying any element or any value, for example you define the my array, right? And we have say we've given some values here, right? For example, first element value to change from 1, it become 100. So just say the variable name my array, variable of the name of the array, which is my array. Then in the third brackets, just mention the element index. For example, the index in array start from 0. So if you want to change the value of first element, you should mention 0. If you want to change the value of the second element, then you give it 1. But in this example, I have just tried to modify the value of the first element, which is 0, and made it to 100. Okay. Then the fourth common operation I'm talking about is passing arrays to function. Okay. Now we can pass arrays to function, but remember that only pass the copy of the array and it will not be a reference. So if you modify, say after we get the variable value in the as a parameter in the array, and if you make modification to the array, it will not change the array value. It will change the array value, but it will not change the original array. Okay, I'll show example to make it more simplified for you guys. Then the fifth example was comparing arrays. Okay, so we can compare two arrays if it's kind of same type using double equal operator. Okay, now enough talk. Let me show you how it's get done. The common operation code we will find in array underscore common operation Go file. Okay, and let me just clean up the screen a bit. It's too cluttery. Okay, I hope you guys can see it. So here, package main. This is a common syntax, right? Nothing new to you guys now. I have created a function. I will come to that later on. But this is the main part. Okay. The first was initializing array, so which is calling it the original array, because we will be doing a lot of common operation with this particular array, right? So in original array, we are saying using shorthand to declare it. Now you know what I'm talking about declaration. So we are declaring it. We are saying it's a 5 element array where the values are 1, 2, 3, 4, 5. Okay. Now if we want to print the length, we want to check the length of the array. How to do it? The len function, len, then in the first bracket, just pass the array and it will return the length, and you can print that one. Then if you want to copy it, for example, you are creating another variable, the copy variable of original array. So copy of this original array. Okay. So var copied array equals this original array, and then we are checking we're just printing the value of this copied array. Okay. Then we are modifying arrays. Okay. What you're doing? So we have this original array. Okay. So original array, like this one, we pass in a function called modify array, and this is how you can pass the value, by the way. So in that, we just pass the original array. So this array we passed to this function modify array. Okay. And how you print, just saying modify array shorthand equals then modify array the function name, and first element or first parameter is the actual array. Second parameter is what is the index you have to change, and the third parameter is actually what should be the value of this second index. Okay. So how we declare this function modify array? Let's understand the function now. So this function, how to declare a function, by the way, to use the func keyword, then give the space and then the function name, which is modify array. Then in the first bracket, you specify what are the parameters. Okay. So here 3 parameters, right? And what will be the data type? The name of the parameter that you're defining here, and what will be the data type that you're going to accept there. So the first element is of course array, and you're saying array of what? 5 element array of integers. Then in the second parameter, you're saying what is the index. Okay. And the index, we are saying that integer value. Then the value of the particular index, you want to change it. Okay. So value, and then the value is of course integer, because in the array we can hold only integer value only, right? So, and what the function does, it's getting the array here, then this index value 1, 2, 3, 4, 5, whatever it is you're passing, then the value you're going to set. Okay. So value you're setting in, and then we are returning the array itself. So while returning the array, what should be the return type? Array only, right? So array is data type, which is 5. Then the integer, which is the 5 element integer, 5 items integer array, right? So that you are returning. Then if you go back, then we are just printing the modified array after getting the modified array value. Okay. So which is simply we will pass the original, but remember, in array, the value doesn't change if we modify it, okay? Because the value getting passed by the value only, not by the reference. You'll understand after I run this code anyway. Then since we are getting a modified value or the change value, we're checking is the original array equal to modified array, which is not. It will of course give me false. And then we're comparing original array with the copied array where the value should be exactly same. And if you're doing the equals here, it should be coming as a true, right? So now let me quickly run this code and see what is the output here. Okay, so just go run, then array, then common operations. Okay, and see, let's go one by one. First is that we are printing the length of the array, okay, using the length function, and it printed what? 5, because we actually have 1, 2, 3, 4, 5 elements, right? Then the copied array, we say var copied array equal to original array, which is again it printed the exact same array, right? So 1, 2, 3, 4, 5. Then we modified the array using a function, okay? So we use a modify array function where the second, that means the 2 means what? Array start from where? Array start from the 0 index. So 0, 1, 2. So that means the third. So 2 means third element got modified, which is why third element is now 10. Okay. And then we are comparing. So we are comparing first with what? Original array. This is 1, 2, 3, 4, 5 against the modified array, which is 1, 2, 10, 4, 5, which is what? The third element got changed, which is 0, 1, 2. 2 means like 2 index means it's the third item. Okay. So as array start from 0. Okay. Now it is of course not equal. Like this value is actually not equal like this, right? So that's why it's false. In the second, we compare what? Original array with the copied array, which is again same value 1, 2, 3, 4, 5. That is why when we compare, it was equal. Now we have covered all the array common operation. There are few more specific cases I want to cover. Let me show you. Let's learn how to iterate over arrays, and this is very important, okay? Because we'll be using a lot of this array iteration or similar. To iterate over array, there is two ways. First, using the traditional loop, using the for loop, and then the second way using the range loop. So first, let me show you how it's that using the for loop. If you see here, first we are defining an array variable which is numbers, short and equals. Then how many item this array can hold? 5. That's why in the third bracket you are saying 5. Then we are saying we are also assigning the values. So 1, 2, 3, 4, 5. Then we are running the loop using the for loop. So for, then plus start value I. So I is equals to 0. So this particular iteration start from 0. Then what is the condition? Condition is I less than the length of the numbers, so which is 5. Then I plus plus. So it will increase one by one. Then inside the loop, so inside the second brackets, we are saying fmt.println numbers. In the numbers, we are giving the I, because to access a value, we have to use the variable name, and in the third brackets, we have to mention the index. That is how we can access the value. So this is one way. Then using the range loop. So how is using the range loop? So numbers equals again the same value. So 5 integer and 5 element we are assigning while even declaring the values 1, 2, 3, 4, 5. Then looping part, you're using for loop of course, but for index comma value equals, or say shorthand equals the range numbers. Okay, so you are using what? For keyword, then index value. So index and value will come from where? The numbers. Okay, and it will loop through, and every time we'll just print the index and value. Index is what? 0, 1, 2, 3, 4, and values is what? 1, 2, 3, 4, 5. Okay, this will be more clear. Okay, now when using this for loop with the range numbers for index and value, so each loop when it's iterate, in the index we will have the index value, which is array always start from the 0 index, so 0, 1, 2, 3, 4, and the value, actual value 1, 2, 3, 4, 5, and we're just printing both. Okay, so let me show you practically in the coding how it's get done, and it will be much more clearer then. So if you come to the array iteration, this array underscore iteration.go file, you will see the loops are like, this is the 2 iteration example are there. In the first, again, we're just defining the same like numbers. The numbers then equals the shorthand equals the number of element will be there in the 5 in this array, and also assigning the value. Of course, this is the data type, and the value is 10, 20, 30, 40, 50. Okay. Now, using traditional loop for I, initial, the loop will start from the I equal to 0. So 0 is starting. Then the condition, how many times the loop will run, I less than the length of the number, which is 5. So less than 5 is 4. So 0 to 4 what? 5 times. Okay. And I plus plus. So it will keep running till the condition succeed. Okay. It will incremental is by 1. Okay. Then what you're doing, you're printing the index, which is I, and the value, which is actual value. And how to access the actual value? Using the variable name. Then in the third brackets, just pass the index value dynamically. We're just giving the variable, and it will access the value directly. Okay. And then for the second example, which is the second loop example, again for keyword, but with a range. So for with range, for index and value. So every time iteration happens, and iteration will happen for what? Range to 0 to 4. Okay. So that means 1 to 5, which is ultimately index wise 0 to 4. So index and value. So if this range numbers, this loop, while iterating, I will have the index value and the actual value. Okay. So while printing in the index, you will see the actual index of the array, and the value, actual value of the array. Now let me run, and it will become so clear. Just have to run it. Okay. So go run, then array iteration. Now you see for the first loop, it printed what? 0, and value is what? 10. For the index 1, the value is what? 20. For index 2, value is what? 30. For index 3, that is the here. So item 4. Okay. So index 3 means item 4. The value is what? 40. Index 4 means item 5, and the value is what? 50. So this is how the iteration happens. Same iteration kind of happen with the range loop. Okay. So using for range. Okay. So range numbers, it iterate starting like through there, and in the index, every time it runs, for index we get actual index again. So 0, 1, 2, 3, 4, and in the value we are getting 10, 20, 30, 40, 50. And in practical life, we'll be using loop a lot. Okay. So you make sure you understand this one better. If you don't understand, rewatch the video again, no problem, or reach out to me for more clarification. I hope it's clear, but if not, of course, feel free to reach me out. Okay. So these are the different 2 ways specifically we can iterate through the arrays. Okay. Now let's discuss a bit further about the multi-dimensional arrays. Now, what are exactly multi-dimensional arrays? A multi-dimensional array is essentially an array of array. Okay. And the most common type is a 2D array, often used to represent metrics or grids. Okay. Now let me show you a quick example, then it will become a lot more clear. Okay. The multi-dimensional array example file you will find in 2D underscore array and 3D underscore array, but main example I have showing here is in the 2D underscore array. Okay. And in this file, you will see I'm using a variable called matrix, which is of course a array variable. And there, the first item, is a fixed size, represents the number of actual arrays inside the main array. Okay, inside matrix, main items are 3. Then the next one represents in each of the arrays inside the matrix array, how many items will be there. There we are saying, so each array item will have 3 items. Okay, so essentially like it will be a item of 3 elements on array. Okay, so 3 and 3, total 9 array items. Okay, now in the count, see count 1, you're starting the like from 1. This is why the value is starting from 1 here. Okay, so we are running in the first loop. I is running. I is for what? I is for this, because if you see matrix I here in the internal J, will come to that. So we are storing the value. This is I representing this one, first count or first outer count. Then in the J is the representing this one. Okay, now I is starting from 0, it will run till 3, and j is also starting from 0 and it run to up to 3. So which is ultimately from starting from 0, so 0 1 2, which is ultimately 3 times the loop will run for each cases. Now in the first loop, I is what? 0, and so in the I, and the j is what? J is also 0. So that's how first one it's 1, because we are starting the count from 1. Second time, again always remember, in the loop it's the internal array that should complete first. Okay, so j is what? J is also 0 0, this representing this value 1. Then j is actually 1. Okay, so 0 1, which is representing this one. So 0 of the first index is 0 here, and the second index is 1 here. So this is 1 2, because we are increasing count by 1. So 1 plus 1 2. Then in the when the count is what? After 2, 1 is 2. 2 represents the third one. Okay, the third one we have the value as 3. So then j1 is over. Okay, so it's now next loop. I is what? I is 1. So that means in actually the value is the index is 1. That means this is the second item. Okay, and the values will start from what? 4, because the 3 increase after 3, it's 4. Then j will run fast, right? So 5 and 6, and after the loop exit, again I will become what? I will become 2, right? 2 in the sense what? 2 in the sense index is 2, the actual representation element is the third one. Okay, the final loop. And third loop, because the end was 6, so next was 6 plus 1 7, 8 and 9. This is how the value will are putting inside each of the shells or each of the items. Okay, this is the way. And for the representation wise or visual representation, we are using like this. So we are running the loop again, I and j, and we're just printing the value. If you want to access each of the items value, we have to use the I and j, and then only. So 0 1 0 2, then 1 1 1 2 1, like this we're going to be accessing all the values and we're printing it. So let's run again. We'll see 1 2 3 4 5 6. So this is ultimately we are storing the value here first and then representing the value using this. Okay, so this is how we can use arrays or multi-dimensional array as kind of a matrix or grid way. Okay, now let's learn about the slices. Okay, now as a reminder, what exactly are the slices? So slices are a key data type in Go, providing a more flexible, dynamic and powerful alternative to arrays. Mark the word dynamic, because that is the most important part here. Okay, now what are the characteristics of Go slices then? Dynamic size. Now a slice is dynamically sized, flexible view into the element of an array, but it's not array, just like array but not exactly array. Okay, and slices are dynamic and can grow or shrink. So what this means is that array was fixed. So number of item in array you cannot add or delete. You can modify the values but cannot add or delete that one. Okay, but in slices you can add as many as item you want to add or delete anytime you want. Okay, so that dynamic, that flexibility slices gives us. Okay, the second characteristics is the reference type. Now array was what? Value type, right? So unlike arrays, slices are reference type. So if you pass, say if you pass one variable value to another variable, or if you pass the variable to function, and if the value change you do in the function or maybe another variable, the original variable value will also change, because you're passing the data by reference. So any change you do in after passing to another function or another variable, that will reflect in the original variable as well. While as in array, it was not the case. In array, if you pass the variable to say copy that variable value to another variable, and or maybe pass the variable to a function, it is passing by the value, is copying the value, not passing as a reference. So you choose any change you do in the array in after passing in the function or as a copying to another variable, that will not reflect to the original variable. But here it's not the case. Here if you pass say a slice variable to say one slice variable to another slice variable and you make changes to new variable, then original variable value also change. If you pass the slices variable to a function and make changes in the inside a function, even such that way, In that case also, original slices value will change. Okay, that is reference type. Now, just like array, here also I want to cover the different ways to declare slices in Go. First one, using the word keyword, and now by now you know it's very easy. The word keyword, then the slice variable name, and then in the third bracket, but don't mention any number. Okay, and then after the third bracket you mention what is the data type. Okay, then using string slice literal, which is the shorthand, using first just mention the variable name, then colon equals, which is the shorthand, equals, again third bracket, but don't mention any number. Very important, this is what makes difference from the array. In array you mention the number, in slices you don't mention the number. Okay, and then the data type, and after that you pass on the value. So 1 2 3 for example. Okay, now there is one special way to make slices, okay, in Go, using the make functions. Now what are these make functions? Make functions kind of a inbuilt function available in Go, which help us to do a lot of things. For example, here we are creating slices. Okay, so first example you see with just the length, okay, but no capacity. In the second one you see with length and capacity. Okay, now first example, my slice colon equals shorthand equal to make the function. Inside that you are passing the data type of the 5 items, and of course the item number is 5, which is mentioning. After mentioning the particular data type, you just comma and give the number, then it will be length. Okay, and then after that in the second example, if you see my, in the third example, second item, my slice equal to colon equals then make the function, then first brackets, inside that you mention the data type first, and then the second is 5, which means the number of length, and the 10 is capacity. Now it's dynamic, right? What about this capacity and all that? So capacity is just to help you to allocate memory and for better optimization of the code. You just mention it. Okay, now you keep adding the items, and the capacity will also double up as per that. Okay, you don't have to do anything manually in that case. Now the fourth option, you can create a slice from the array itself. Okay, and if you see the example, ARR has been the array, colon equals shorthand, that is in the third brackets we mention the number of elements, that is 5, then we give the values also, assigning the values 1 2 3 4 5. Now how I can create a slice from this array? So my slice, that is a slice variable name, colon equals, then the original array, that is ARR, then the third brackets mention from which index to which index you want to copy, create the slice. So 1 is to 4, and it creates a slice including elements at index 1 2 and 3. Okay, now enough talk, let me show you in hands-on way. The slices declaration code file you will find in slices, then underscore declaration.go, and here you see this is the first one, that is using the word keyword without initialization, that is word slice, then the third brackets open closing without mentioning the particular number of items, then the data type, and we're just printing it, just showing you. And by the way, if you declare a slice and don't mention the any of course you don't mention the number of items and int the value, there is no default value. Okay, it's just, of course there is default value, but it's nil. Okay, because you are not putting any items, you don't know the items, right? So it's nil. Okay, then in the second one we initialize a slice, just like slice 1, then of course opening closing of the third brackets, then the data type of the elements, and then the items. Okay, and we're printing it. In the second one using slice literal, so slice 2, then you see that we are using again opening closing of the third brackets, the data type integer 4 5 6, and we're printing it. Third one, you're using make function. Okay, and using this make, so you can see the even the definition also. Okay, so make is a built-in function, allocate and initialize the object. Okay, so this doing here, so we are creating slice of integer and the length is 3. Okay, and we are putting the values also inside 0 1 2. Okay, and all are nil, by the way. Now why not just print the values also before assigning the value? Okay, so slice 3 before putting value. Okay, then after putting the value, of course, and then see, we are creating a slice with the length and capacity. Okay, and here also I'm printing what will be the capacity after putting three values. Okay, and then the fifth one from array. This array. Then in the array we have 10, 12, 11, 12, 13, and from slicing from 1 to 3. Okay, excluding the index 4. So if you want to just copy 1, 2, 3, then you have to mention till 4. So just before the ending index, it will create the slice. Okay, so that is variable is slice 5. So let's print it, and looking at the value, it will make more understanding. Okay, so let's clear this up, and now let's run it. So go run slices declaration. Okay, and if you see here, the first one, that is this one, non-initialized, and what is the value? Like nothing, right? No zero value. So if it was a zero value, then it would have been say 0, right? But nothing, nil. Second case, you see here, there's initialize before using it. Okay, so that's, of course, we are initializing the slices or declaring it, and after that, see, we are just passing like how to add the values to a slice. So we are saying slice equal, and this is initial. So we declare it. Now the declared variable, we are assigning the value like this: slice, then opening closing third bracket int, the data type, and the value here. And we are printing here, which you have 1, 2, 3, and then using the slice literal or shorthand. Okay, so slice 2, then of course opening closing of the third brackets, which mentions the slice values, then the data type integer, and we are having 4, 5, 6, and we're printing it. Then in the third one, we are using make function to create slices with length and capacity. So first one, the length and capacity both is 3, and you are printing the, just to be double sure, what are the values. So why this is important? Because you remember when we created the slice, value was nil. Okay, but if you want for the better memory allocation and better optimized performance, you want to initialize the variable itself. So you create a slice using make and put the capacity, and for each the values, okay, it put a placeholder, default value. See, 0, 0, 0. But before it was not there. After you use the make function and mention the length, it's create for that 3 only, and that is how we are adding the values here. It's not appending or say adding or deleting. Okay, because as I say, any data type by default in Go will not have any inbuilt function, but we should be using the like default or say not inbuilt function, external function. Okay, now, and because we have total 3 items, 0, 1, 2, so 0, 1, and 2, we are assigning value 7, 8, 9, and we are printing here. You can see slice 3, 7, 8, 9, and see, while printing in slice 4 is printing what? 7, 8, 9, right? Just like it's mentioned here. Now we are like, say, at this state, I mean, after you're printing this, you're adding 2 more. So slice, see, 10, we're using append function. Okay, in append is used to add the new element to the existing slice. Okay, so in append, first mention the slice that you want to modify, add, and there what is the value you want to add in the second parameter. Okay, this that way we are first adding, I mean, we are adding to 10 as a, say, 1, 2, I mean 0, 1, 2 in the third index, and in the fourth index we are saying 11. So we have now 5 element. Okay, and if we add a print there, okay, after adding or after append, okay, and say we're printing it. See, after append is what? 0, 1, 2, 3, 4. Okay, so ultimately 5 items. Okay, with 4 till 4 index. Okay, now if you check the capacity, okay, capacity is what? 5. Okay, now the moment I add append new values, just 2 values. Okay, I'm adding 2 values and then checking the capacity, what will be the value? See, the moment I added 12 and 13, let's just print also just for better understanding. not capacity, but after again append, after append again. So you see the value is what? After append again, 1, 2, 3, 4, 5, 6, 7. Okay, so we have now 7 element. So when we had 5 element, the capacity was 5 because as we defined, the moment you keep adding more than 5, go automatically add up the capacity, double the capacity. From 5, it become what? 10. The moment you reach 10, it will make the capacity as 20. This is how it optimizes memory management. Okay. And in the fourth one, you see from an array. So we are getting slice from an array. Okay. And the array is what? Array. Then of course colon equals shorthand. Then you are mentioning this array of 5 items. And the data is integer. And what are the values? 10, 11, 12, 13, 14. Now we are going to create a slice from this particular array. So you're saying slice 5 colon equals shorthand. Then array. This particular array. Now in the third brackets, we are mentioning from which index till which index. Okay, not 2 but till which index. This 4. So it slices from array index 1 to 3. Now how many values we had? 0, 0 index 10, 1 index 11, 2 index 12, 3 index 13 and the fourth index 14. Okay. Now we are slicing from 1 index, that is from 11 till 4th. Okay. So 1, 2, 3. Okay. So 1, 2, 3. So 11, 12 and 13. These 3 items we are going to slice from the array. Okay. And if you see the printed value slice should be slice 5. Okay. So slice 5, the values are what? Slice 5, it's 11, 12 and 13. Okay. So this is how we can create slice from an array. Now that we have learned the different ways how to declare and slice, let me show you some very common operation that we do with the slice. Now this is exactly similar to array, just some additions. Okay, let me quickly show you and it will become a lot clearer. Okay, so the first thing is the length and capacity. Now length you already saw, we can use that length function in the array. Same here. For capacity, we have to use a built-in function called cap, and then it will show the capacity of the particular slice. Now appending to slice. Now as I say few minutes back that for other programming languages, they offer with the data itself, the data type of variable itself, the inbuilt function, but that is not available in Go. In Go, to work with different variable types, you have some dedicated function, built-in functions. Okay. For example, with slice, if you want to add a new element, you have to use a built-in function called append. And in append function, in the first brackets, the first element, the first parameter will be the slice variable that you want to add a new item, comma, then the value that you want to add to the particular slice. Okay. And suppose to slice a slice. Okay. So like just like from the array you create a slice. So from the slice, existing slice, you can create another slice. Okay. How to do that? So again, exact same. So the actual slice, for example, here numbers, you can see that here. Then same method in the third brackets from the index that you want to create the slice, then colon, then till which index you want to create the slice. So 1 colon 4. The for example, you can also like don't have to mention the starting, but just the ending part. For example, first two number, say like in the beginning there is no value, in the colon and in the end till 2. That means 0, 1 you are creating a slice for the index values 0 and 1. Okay. 2 you are not doing it. Okay, because remember that the after colon you mentioned until, not include that one. Okay. Like if you want to create a new slice, now just like beginning you can skip giving the like from which to start. That means the very, if you don't mention at the beginning of colon what to start from, it will just think of like all the elements before the ending. Similar way you can give the beginning that particular from which index, then don't give any any index value, it will assume you are getting slice from the mentioned value, that's index 2 to the rest of the elements. Okay. Then now the fourth most common operation is delete an element from slice. Now for example, suppose I want to remove an item at index 2. Now how exactly in Go we can remove that particular index 2 element? Now there is no particular separate function. Instead, we're going to use the append function. How gonna do that? For example, the original slice variable is numbers. Okay. Now we're going to reassign the value. So numbers is equal to append function, then the first bracket, then the point just before the index 2, you keep like you have the slices. I'm creating a new slice, okay, using the append. So append, then the numbers, then in the third brackets colon 2. That means before the second element 0 and 1, okay, we are keeping. Then comma, what are the item or values you are adding? For that is the numbers, then in the third brackets 3, then colon. What that means? From 3 to rest of the indexes. And what happening? We are skipping the second element. So we are not including the second element. And this is how before the index, like second index, we are keeping all the value. And from the 3 to the rest of the elements, we are keeping the value. This is how we can remove the second index. Now the index can be anything, and you can use the variable to dynamically calculate the final slice value here, which is very innovative way, by the way. The fifth one is the checking if the slice is empty or not, and this is very easy. You use the len function. So if len, then the slice variable equal 0, that means no value, right? I mean, that means no elements, and you can say slice is empty. Okay. Now how to sort a slice? For that, there is a very good inbuilt library available, or say module available, which is you have to import, okay, or package, whatever you want to call it. So import short, then use the short.int. If it is the slice of integers, use the sort dot ints. If it's strings, then use the short.string, then the slices of strings. Okay. Then the seventh point is the finding an element in the slice. Now, if you would like to find an element in the slice, there are many ways, but I think the most efficient way are the using for range loop. Okay. So we're using what? For underscore, then comma, then the value. So underscore mean the index, and v for the value. Now, if you're not going to use the index key, you should not give any key name. Use the underscore. That way, Go will not error out, even if you're not using the underscore. Okay. Then inside the code block, we are saying if v is what? The value for each iteration. So if v equal target value, that means it's matching. So target value was what we are looking for, right? Now, let me show you all these 7 common operations in the script or in hands-on way. Okay. That way it will become more simpler. Let me show you. The slices common operation file is actually slices underscore common underscore operation.go file. And let's look at it. Okay. As we discussed in the slide, so we are showing you how first we are defining our initial slice, original slice, for example. Then we'll be checking the length and capacity using length and cap. Okay, when printing also. Then using the append function. Again, reminder, very important, the variables doesn't come inbuilt with the functions. So we have to use the built-in separate functions. For example, the append function here. Okay, so you're using append function. In that append function, you have to first provide the slice, original slice, and then the value that you're going to add to the slice. Okay, for example, we have this slice, right? Original slice. There you're adding a new value 7. Okay, then slicing a slice. For example, we have one slice, that is slice. Okay, from that we are going to get another slice. How to create that? For that we'll be using slice. Then in the third brackets, mention that from which index till which index you want to copy. Of course, if we skip the first one, then from the very beginning, and if you don't give the second one, that means till end. Okay, from that you are getting a sub slice. Okay, then we are deleting. How to delete? Again, very easy. So we are going to again use the append function. In that, in the source, just take the original slice till the point that you want to skip. For example, I want to remove the third element or index at 3. Okay, then in the first element as a source element, you are using slice. Then in the beginning, we are not giving any value. That means from the beginning of the index till how much? The third index. So it will take the items till the third index. Okay, then comma. Then what are the values you're going to add? What are the elements we are adding? So that is slice. Then the beginning of the index is 4. So from 4 to, and we are not giving anything. That means till the end. That means we are joining two values from the beginning till just before the third index, and any values that is after 30, that is from 4. Okay, this is how we are removing the item index 3. Okay, and you're adding the value back to the slice. Okay, then how to check if a slice is empty or not? Simply use the len function. So len, then in the first brackets mention which slice value you're checking, and if equal 0, that means doesn't have any items in that particular slice. If it's not empty, there is else function, and you see it's not empty, right? Then to sort, if you want to sort, use the sort package, and you can import that. So import the sort package. Okay, and sort dot ints, because the slice that we have here is the value of integers, right? So that's why sort dot int. Okay, and then in the brackets just mention the actual slice variable, and this is how you can sort the values. Then suppose I want to find, so we have 1 like 3 2 1 1 3 1 4 5, all these values, right? And I want to find the fifth element. Okay, and how can you do it? So when you're using element to find, we're giving the values that 5 want to find out, and if found, then there's a flag I'm mentioning, boolean value false, didn't found. If found, then it will become true. Okay, so we are using what? For loop and underscore, that means index, but if you don't use it, it's fine. But if you mention just like index and don't use it, it will error out. Okay, so that's why underscore to skip. I mean, even if you don't use it, it will not error out. Then comma, then v, which is the value. Okay, and you're using range keyword to loop through each slices. Okay, or each item of the slice, and this is iteration for each of the iteration, the index and value. So you're checking in the first, in the different iteration, you're checking if v equal, so it will move like first item. If it's 3 equal 5, no. 1 equal 5, no. 4 equal 5, no. The moment it's a 5 equal 5, okay, like in the v variable, the value become file in some iteration, then it will become like the flag found will become true. Okay, and you have and you're just printing if found, then element found in the slice. If not found, we will say element not found in the slice. Okay, now let's quickly run this and show you. So let's run go run slices, then common operations. Okay, and see, is printing original slice was 3 1 2 4, like that. Length, we can use a length function, so len. And for capacity, like what is the capacity? Of course it's 11, because if you don't mention like while creating slice, if you don't mention the capacity and length, it will automatically take the capacity as same as length. Okay, if you use make function, that become different, by the way. Now after appending, of course we are adding 7 here. So using append function, we are adding 7, so it's getting added as 7. Now sub slice, okay, we create from what? From this second element, okay, 4, from 4 to till what? Fifth, like before fifth element. So 4 0 1 2 2 1 3. So 4 1 5. 4 1 5 will just create a subslice, and see the subslice 4 1 5. Then delete an element. It's also, as I explained, so in the using the append function to append the all the slice value before the third index and all the kind of subslice. Okay. Oh, make sure that you check this point while adding the like say rest of the elements. We are using these 3 dots. If you miss that one, it will be problem. Okay, so make sure you have this 3 dots. Okay, that's how all the values will get added with the original slice. Okay, not original, say the first slice element will get added with the second slice element. Okay, and that's how we are removing the, see, they are removing the third index. Okay, index 3 of what? 0 1 3 4. Okay, sorry, 0 1 3 4. So because 3, that means the element 4. So 0 1 2 3, 1 get removed. So 0 1 2 3, so it's become 5, right? It was the fourth element, so it becomes the third element. Okay, now the third element, it's become the fourth element. Okay, that is the third index it become. Now after that, slices, I mean, we are checking the condition because slices have the values. Of course, it's not empty, so it's saying the slice is not empty. Then we are shorting it. See, it's become 1 2 3 3 4 5. So because we have the duplicate elements, it's shorted out because we use the shorted ends. Then we check that did we found the element 5 or not? Yes, we have the like 3 5 we have, right? Suppose I'm giving some value which is not present. Okay, 10 is not present. If you run it, see, you say element 10 is not found in the slice. So this is how you can use different ways. Again, as things move forward, we'll be exploring a lot of advanced uses of slice. Look for that. Now let's understand how to iterate over the slices. And not to your surprise, you guys now have a guessed. This just like how we iterate through the arrays, we can use the exact same way to iterate over the slices as well. Let me quickly show you. So the slices iteration example we'll find in the slices underscore iteration.go. And here I have defined a slice that is strings apple, banana, cherry, date, and the elderberry. Okay, I'm iterating through using the for loop first, like normal for loop. Okay, where I'm defining, say, I is equal to 0, I less than the length of the slice, then I plus plus. Okay, and we are returning for each iteration, we are just printing the index value and the string that we have here, %s. Okay, and using a printf method. Okay, in the iteration using the range, we are using for, then each iteration you are fetching index and the value equals like the range keyword to fetch the loop through the each iteration of the slice, and we are printing again the index, which is the index here, and the value, that is we are putting the value here. Okay, now the value is the string type, so that %s. If it's the integer type, then %d. Okay, and you are going to run it. Okay, and you're going to run it exactly just like how we did for the arrays. Okay, so go run and slices, then iteration.go. You see, for the first one, of course, index is 0, value apple, index is 1, so value is banana, index is 2, value is cherry, index is 3, then the value is date, index is 4, the value is the elderberry. Okay, like this. Now remember, and always remember, if you are just newly starting, for array or for this slices, both the cases the index start from 0. So 0 is apple, 1 is the banana, which is the second element, cherry is the third item, will be the index will be 2, because the index itself starting from 0. That is the important part. And you saw the looping through exactly same for the, or similar for the range also, we iterate through all the values. Okay, now if you ask me which is the most efficient one, I will say this. I will suggest use the range based loop, again based on your use case, but I think this range wise slicing is the better. Okay, now before moving to the next topic, I want to show you the value by reference thing in the slices. Okay, because if you remember for the array, so let's go to the array declaration also. I think declaration, no, in the array common operation. Now when we are explaining array common operations, there we pass the that array variable to the function and show that the array passing the was by value, not by the reference. So even if you made modification in the array, it would not change the actual or original value of array. Now let me show why it's different for slices from array. What is this by reference I was talking about? Let me show you. So the slices value passing reference example we'll find in the file called slices underscore pass by reference.go file. Okay, so let's understand this code first. So I have one function and very easy function. Okay, func, using the keyword func we define the function. Function name is the modify slice, and as an input parameter we are using s as the input parameter name. Then what is the type of that particular this name or the variable is the slice, because we are not giving any particular value, and int is int values. It can the item can be int values. Okay, and what you're doing, if is the length, we are length of this particular input parameter you're getting is greater than 0, then in the 0th value, so or the 0 index, we are making change to or modifying to 999. Okay, it can be any value. Just as example I'm showing that. Okay, I'm just printing after modification, and in the main, first I'm creating a original slice variable. Now how to identify it's a slice? By this, always remember that. Then what is the type of the each element will be what type? Okay, that is integer type. Okay, 1 2 3 4 5 like that. I'm printing that after just defining it. Then we are modifying. Okay, modifying what? Modify slice. Again, remember, I'm not assigning the value again to this original, like I'm not returning any value in this function at all. I'm not assigning that new value to original slice. But since a slice, when you pass the variable to any function, it passed by the reference and not by the value. The moment we modify in this function, the original variable, original slice variable value will also change. Okay, and then I'm printing again this original slice after modification. So let me quickly run it so that it will become more clear what I was explaining of this value passing by reference I'm saying. So go run and slices, then pass by reference.go. See that first we defined original slice and then we printed. So original slice before modification was 1 2 3 4 5. After the modification, again we didn't assign the new value to original slice, we just pass it to a function. Okay, and in the 0 or the 0th index, the first item or first element become 999. So, and when printing, see the inside modify slice function, after modification the value is 999, then 2 3 4 5. Okay, and after this function is done, again you're printing original slice after modification, that the value is original slice after modification exact same when you print it inside the function, which is 999 2 3 4 5. So that means when you pass the original size variable to a function or maybe copy to another variable and make the changes, it changes the original slice variable as well. So be careful while working with the slices on this matter. Okay, now let's understand about the maps. Okay, now what are exactly maps? So a map in Go are the key data structure used for storing and retrieving data efficiently. They are very similar to dictionaries or hash table in other programming languages. What are the main characteristics of Go maps? First, the efficiency. So map provide efficient lookup, insertion and deletion operations, of course, and I'll show you. The second characteristics is the flexibility. So they can be used to represent complex data structure. Third one, dynamic sizing. So maps can grow as needed, making them flexible for data when varies size or any kind of data type. Okay, and the reference type. So maps are the reference type, just like slices. When you like say pass the main variable, origin variable to other function or other copy to other variable or pass to another function, inside the function you make change. For maps also, original map variable data will change. Okay, so maps are reference type. Passing a map to a function allow the function to modify the original map. Always remember that part. Okay, now let's learn what are the different ways we can declare maps in Go. First one, using the word keyword without initializing it, and this is similar to the other different ways like for slices or arrays. Using word keyword, then the variable name, for example m, then space the data type, which is map, then inside third bracket key type, which is could be integer, string or maybe custom type, and then the after that third bracket closing the value type, again it can also be custom type. Okay, For example, word m, then space map, then inside the third bracket string. So the key will be string, and after that the value type will be integer. Okay, so key will be string and value will be integer. Okay, then using the map literal. For example, m then colon equals, which is the shorthand of declaration, then map, and inside third brackets, which is the key data type, will be string, and after the third bracket closing, the int will be the value type. Okay, and in the opening closing of the second brackets, we mention the internal key and values. Okay, for example, apple is the key and the value is 5. For example, banana is the key, which is the string type, and the value is 10, which is the integer type. Okay, then the third way, using make function. Okay, and how to use the make function? Here also you will use the shorthand. So m colon equals, then the make function, and inside the make function we have to mention the data type. Okay, so there we are mentioning map, and what is the structure of this map? In the third brackets, string. So the key will be the string data type, and after the third bracket closing, in, that means the value will be integer type. Okay, then the fourth way, using make function with specific size. Okay, so here m then colon equals your shorthand, then make function make, and in the opening closing of the first brackets we mention the map, which is the map data type, then the opening closing of third brackets we mention the key type, then after the closing of third bracket we mention the value type, and then just a comma, and you mention the initial size. Okay, and I'll show the example, don't worry. Now the fifth way is using struct as map values. Okay, so map can also have struct type as values, allowing for a more complex data structure. Okay, so example wise here, type, then the custom type is product, and the struct, so it's a custom struct, right, or custom data type struct, and the internal fields are name, which type is string, price, which type is the float 64. Okay, then how we are going to use the struct as map? We're going to use products colon equals, which is shorthand, then make, then make function. Okay, make, then opening closing of the first bracket, then map, then opening closing of the third bracket. As key we mention the key in data type will be integer, so int, and then we mention the what is the value type. Value type we are saying product, right? So we are using product as a value inside a map. Okay, then come to the more complex type, which is nested maps. Okay, and what is the structure of that? So the variable name, for example here company, then we say company colon equals shorthand equals that map, and opening closing of the first bracket mention map, then the key type here is the string, inside that key as a value. So after the first map we are mentioning again map, right? So first map is the key, okay, and the second map is becoming the value, and that is map. So second, the values, inside the values, the first key is the integer, and that value is string. Again, I'm going to show you practically, then all these things become more simple to you guys. Let me show you. The map declaration file, example file, is actually called map underscore declaration.go file. There you'll find all the codes related to the declaration of map. Okay, there the first one is using the word keyword without initializing. So we are going to declare a map variable without initializing it. How it's happened? So we say word keyword and the variable name, then the data type, which is map here. Then inside map, what is the key data type? Okay, so a string, the values data type is integer. Okay, then using a map literal, which is in the shorthand. So map, the map to is the variable name colon equals shorthand, then the data type, which is the map, then maps what is the key type, which is string, and what is the value type, integer. And while doing the shorthand, we have to mention the values as well, right? So value, we are saying this string, the key should be string, right? So apple, and value should be integer, right? So value is 5. And another value is that the key is banana and value is 7. Okay, now using the make function, so map 3 colon equals shorthand, I'm calling the make function. So make function, again make function is the built-in function allocate and initialize object types. Okay, so make, Then inside the make, we are saying map data type. Then what will be the map's key type, which is string, and the value type is integer. So here map 3 apple, the key type is first we are saying apple is equals to 5, map 3 banana is equal to 7. So this is how we are creating the values, okay, or setting the values. This is how you can assign to the values of different keys in your maps, okay, because map is what, the combination of keys and values data types, okay. Then using make function with specific size. So we are saying map, then make, then same syntax like the previous one, map, then the key type will be string, and the data type is, or value type is the integer. Then 10. So 10 is the initial size. So it will, so make will allocate that memory, okay. Then we are saying maps, again you are assigning value, apple is equal to 5, banana equal to 7, okay. Now map declared without the, with the make function specific size. Then we have the struct as a map values, right? We explained. Here we are using the fruit example. So type fruit struct. So the custom, we are creating custom data type, which is fruit, and the structure of that is, a struct is that the initial internal fields are price integer and color is string, okay. And you can see we are using map, map 5 is the variable name, shorthand equals make, and here we are saying what is the data type, or it's a maps keys and values data types. So map keys data type is string, and values data type, we are not saying string, all that, because we are going to give the custom data type, and custom data type is what, fruit. So fruit, so string, then the fruit. So here say map, then apple, and apples, what are the attributes, the price of the apple, for example 5, and the color is green. Then as key is string, so banana, and banana's attributes are what, banana's attributes are fruit, which is the custom data type, and that's price is integer 7, and the color is yellow. So these are the way you can create the map of different custom structs or custom data types, right? Then the complicated part, the nested apps. So here just try to look at it. The variable name is map6 colon equals, which is the shorthand, equal to make, you're using the make function, then map, then the key type is string, then starting the value type. Now value types, again it's a map, so value is a map, okay. Map of what, map of key is string and value is integer. How it's working, so we are, for example, map, then the key is what, string, right? So map fruit, fruits, what are the fruits you have, we have map, then string, then int. So this is the value word, see map string int. So the key is the apple, the value is 5. So key is the string type apple, value is integer 5. Key is banana, string type, value is integer 7. Similar way, map 6 vegetable, which is map 6 definition wise, map 6 map string, so string, the string type key, then value is, values data type is what, map again, so map, then string, string is what, caret, and value is integer, integer is what, 3, and p is 2, okay. So this is how we can create the nested map. Now let me quickly run this and see the values, then it will become more clear. Just clear the screen a bit. So go run, then map declaration, not go, and see, let's go by the value by value. First we are defining the map, but we are not initializing any value. So what is that, it's become empty map, okay, or null map, okay. So map declared with var keyword without any initialization. Then we declared map with literals, so with initial values. So map apple, as we say, apple 5 and banana 7, okay. Then we use the make function to create a map and then later on assign the values, okay. So map declared with make function, and we assign what, apple is 5, so apple 5, and banana 7, so banana 7, okay. Then we use the map declared with make function and specified sizes, okay. So this one here also we create same sizes. There we are saying that apple, since we have assigned the value of apple is 5 and banana 7, which is coming here. Then we use the custom struct, custom data struct as the map values, okay. And what is that? So map with struct as values. So map apple, Apple have what? Apple have the custom data type, that is price is 5 and the color is green. So 5 green. Then the banana. So banana string, string. Then the fruit. Fruit is what? Custom data type, right? So banana, the price is 7 and the color is yellow. Okay. So this is it's coming here. Then the nested app. So that means in map the keys could be string or anything. Then the values are the map again. Okay. So how it's coming? So nested map fruit. Now fruit is again the value is a map, and there we have apple as 5 and banana as 7. Okay. And same the key is string. Okay. Initial maps key string. Then the value is the vegetables. Okay. So vegetables, then map, because the value is map, and it's carrot 3 and peas 2. So these are the ways we can declare the nested maps. Oh, now let me show you the common operations using map. Okay, very important. Watch carefully. Now let's learn about the common operations of maps. First, we're going to check the length of the map using what? The length function. So length, then the map variable name you have to specify. Then adding elements. To add element in the map is very easy. Just say the map variable name, then opening closing of the third brackets, then put the new key name, okay, and equals to the value. Now if you want to change the existing key value, just mention the existing key name inside the third brackets, then equal to the new value, and it will update the value. Okay. Then retrieving element. For retrieving element, say value, the variable name, shortened equal, then map variable, then in opening closing of third bracket, just mention the key name, and whatever there is a value against that key name, we'll put in the value field. Okay. Then check the existence. You can check the existence by having value, then comma, then okay, then dot, then colon equals, then the map variable key. If the value exists, then okay will be true. If the value doesn't exist, the okay variable become false. Okay. Then deleting the elements. To delete the element or delete the key value from the map, you have to use the function called delete. Inside first brackets, mention the variable, the map variable name, comma, then the key name, and it will remove the key and the value from your map variable. Okay. Now enough talk. Let me quickly show you in the practical. The map's common operational code you'll find in map_common_operation.go file. There, let's understand the code first. So we're initializing a map here. Okay. Let's call the variable name of the map is fruits. Then fruit colon equals shorthand is equal to map, and the key data type is the string and the value type is integer. So accordingly, the key apple, the value is 5, key banana, and the value is 7. We can keep adding. Okay. Then we can check length using the length function. Okay. Which will give us the total length of this map keys. Okay. So for example, apple, banana, say papaya, whatever the key and the value you add, total keys number it will print in the length. Okay. Then how to add a new element to this particular map? Very easy. Just say that particular map variable name, then inside opening and closing of the third bracket, mention the new key name, which is orange, for example, because we have apple, banana, we're adding orange equals 10, and this creates a new key along with the value. Okay, automatically. Then you're printing the fruits to see the updated value. Then how to retrieve the elements? We can retrieve like this. So we want to say get the apple price. Okay. So apple price variable name colon equals the fruits. Fruits is what? The map variable. Then what you want to get? The apple. So apple key, the value is what? 5. So here apple price is equals to fruit, then apple, the integer value will return to this apple price value. Okay. And you're printing that. Then how to check for the existence? To check the existence of a particular key, we have to use the price. If the values exist, we'll get the price. Now this particular, after the result part, okay, you mention after giving the comma, just mention the particular variable. It will become Boolean variable. For example, if the value exists, it will become true. If the value doesn't exist, it will become false. This is how we can check a key exists or not. Okay. So here what you're doing, price, then comma exist, then colon equals to fruit, kiwi. It will check, it will get two values. First, in the price value, if the key exists, it will give the value into, put the value into the price variable. And in the second variable, it will say it's true, present. If the kiwi key doesn't exist in the fruits variable or the fruit map variable, then the price is like no value will be there in the variable. In the exist particular this boolean variable, it become false. Okay. And if it exists, I will print the price of the kiwi. If doesn't exist, then I will print kiwi is not, doesn't exist in the map. Then okay, just to see that this works, I tried with kiwi first, and then we will print, of course, kiwi doesn't exist. Then in the orange price, because orange is actually what you have added while showing the adding element part of the code, right? Then we'll go and delete one particular element from this map, okay, using the key. So to do that, we have to use the delete function, inbuilt function, by the way, inbuilt delete function. Then inside the opening and closing of the first bracket, mention which is the maps variable, which is fruits here, and which key and value it removed. So just have to mention the key, the value will along with the key will get removed. Okay. And then you are printing after deleting banana, what is the final maps variable value. So let's just quickly run it and we'll go through the values, which will make the understanding even better. So go run maps underscore common general operations. Okay. And see, first we are adding apple and banana. So first key value is apple and the second key value is banana. Now while checking the length, it check for the number of keys in a particular map what it has. Okay. That's why it's 2, because you have 2 key, apple and banana. Then you are adding elements. So we are adding what element? We are adding orange. Okay. As 10. This is how, just mention the map particular map variable name. Then third bracket open closing, just mention the new key name equal to, just assign the value, and it will just do that way. And see, while printing, we are printing added orange, and what the value finally become of the map. So map apple 5. So apple have 5 values 5. Banana is 7 and orange is 10 because we just added them here. Okay. Then how to retrieve the elements? Just mention the particular map variable, then opening closing of the third bracket, inside just mention the key, and the value will be assigned to the how you define the variable. Okay. And we are printing the price here. Similar way, you see price of apple, because apple key we are checking the value is 5. So it will get returned to the apple price variable, and that's how printing it. So apple price of apple is 5. Now we are checking the existence. First kiwi. Now kiwi actually doesn't exist in our existing this fruits map variable, right? So it will simply, since this doesn't exist, it will print kiwi doesn't exist in the map, and that's what it printed. Kiwi doesn't exist in the map. Second time we tried that okay, if the orange price exists or orange key exists in our map, which exists by the way, because that we have added later on. See, the orange exists. So it will print the orange price, which is 10. And then we tried the delete function to delete existing key and value from our maps variable. Okay. So fruits is our map variable. From there, we are removing the key banana. While we mention key, it also removes the value as well, which is why in our final map variable, we have apple 5, orange 10, and doesn't exist the banana because we removed that, right? So understand the different common operations of map. Now let me show you how to iterate through the map key and values. Important, isn't it? So for this example, we'll be using the fruit that we just covered, right? That one. And we'll loop through the keys and values. Let me quickly jump to the codes, and the code file for this is the map underscore iteration.go. There, if you see the content of the particular file, which is there, we're just creating a map variable which is called fruits, then colon equals, which is the shorthand, or say we just mention the value, then map. What is the map definition? So map, then the key is string type and the value is integer type, which is why we're assigning apple as the key is the string and value is 5, and same banana and 10. Okay. Then we're adding a new value which is orange as 7, right? Now we are going to iterate through all these 3 key and value element. So for that, we'll be using the range, for and range, okay? For range loop, we can say. So for fruits and quantity equals range fruit. So from range fruits, it's using range is iterating, and each iteration we're getting fruit and quantity. Quantity is what? Okay. Fruit represents the key, the quantity represents the value, okay? And this is whatever variable you want to mention, but always remember the first element here means that it's the key, and the second element mention the value, okay? So now just loop through it, and we're just printing the key and value. So key is fruit and the value is quantity. Just quickly run it. So go run, then map underscore iteration dot go, and see it printed the same way. So apple first element is what? Apple, then banana, and then orange. So apple key, banana key, orange key. Then the value is what? 5, 10, 7, right? So this is the way you can loop through. Again, this is just, you can mention like this key and the value, okay? So key, you mention the key, value, you mention the value. Again, mention while iterating and printing this. See, key is actually what? String. That's why while using fmt.printf, we are using %, and the value is what? Integer type. That's why we're using %d to show the print value, okay? Now let's run again, and let's see exact same print again. Apple 5, banana 10, and orange 3. So it is just to keep it easy. You can use either this way or in a like meaningful name. You can do either way. Again, as a reminder, we're using for keyword to iterate through it. Every iteration will have different key and different value. How is getting it? Range is actually doing the iteration for the fruits, and each iteration this code is going to execute where we will have the access to key and value, and you are just simply using it. So this is the way we can use iteration in maps with Go. Now let's start learning about the pointers. Now what are the pointers? A pointer is a variable that stores the memory address of another variable, okay? Now let's learn about the characteristics of the Go pointers. First point, efficiency. So using pointers can be more efficient for large structs or arrays, as it avoids copying larger amount of data, because you are not passing the array value or some bigger struct values to the different function or other variable. You can just pass the memory reference, which is much smaller, right? Then mutability. Pointers allow you to modify the original variable as well, which is useful in function where you want to change the input data as well. Third point, passing pointers. So you can pass the pointer to different function to modify the original data or to improve performance by avoiding data copying, just like the first point, okay? Then type specific. So pointers in Go are type specific. The fourth point is type specific. So pointers in Go are type specific. A pointer to an int is actually different from the pointer to a string. Very important. Then using the AND operator. So the AND operator is used to get the memory address of on any variable, okay? For example, p colon equals like shortens equals and x. So p's value is actually the memory address of the x, okay? And remember, the moment we are saying p's value is the memory reference of x or say pointer of x, that means the p is actually a pointer variable, okay? Then using the star or asterisk operator. The star or asterisk operator is used to access the value at the address pointed by the pointer. So whatever, say you, for in p for example, you copy the memory address of what? X. Now if you want to get the value of x, you have to use a star p, and it will automatically give the x's original value. Now let's learn about what are the different ways you can declare pointers in Go. The first way is using the var keyword, and you use the var, then the variable name, for example p here, then the asterisk or star int. This declares a pointer using the asterisk symbol, okay, followed by the type of the value. For example, we are creating a pointer of integer, so that's why var p. If it would have been a pointer of string, then var p, then star, then string, okay? Now pointed to an, suppose you want to create a pointer to an existing variable, okay? For that, how will do it? So for example, the existing variable is x. So var x, then space int equals 10. So it's an integer value. Okay. And how to then create a pointer for this integer value? Following way. P, then colon equals, which is a shorthand, and then and x. And what the and operator does? It fetches the memory address of the variable x and store that into the variable p. Okay. Then the third way is creating a pointer with the new function. Okay. So for example here p then colon equals to new function, then inside the first brackets int, and this new function what it does, so it allocates the memory and return a pointer to it. Okay. And this is useful when you want to allocate memory for variable directly without declaring first. So you just don't want to declare it, but allocate the memory as well. Okay. Now the fourth one is pointer to pointer. Sound interesting, isn't it? So for this example, we have, say for example, variable x. Okay, how are you declaring it? Var then space x, which is the variable name x, then space int, which is the data type integer. Now we're creating a pointer of x using how? So var p then space then star int. Star, the moment you see star, that means p is a pointer variable, and equals and sign. And sign again what? And sign is used to get the memory reference of any variable. So and x, so it means it's fetching the memory reference of the variable x and storing in p. Now if you want to create a pointer of p, you can do that. How? For example, here we are creating a variable name pp. So var space pp, which is pointer of another pointer. For this reason, you have to add 2 star because it's a pointer of pointer, right? So 2 asterisk or 2 star, then int, which is the data type, equals and p, because p is what? P is a memory reference of what? X, right? So this is how you can create pointer of pointer, which allow us multi-level of indirection. Okay. Now we have learned it how to declare. So let me show you in practical way. The pointer example we will find in pointer underscore declaration.go file, and there you will see first one is that using var you are declaring the pointer. So var ptr1, which is pointer 1. How we can identify this pointer? By that asterisk sign, okay, or asterisk symbol. Then after that you mention what is the data type of the pointer, which is integer. So it's a pointer of integer value type. Okay. So we'll be printing that. Okay. Then we are creating a pointer of existing variable. For that we are using a variable called value, and we are defining as an integer data type, and we are storing 42 value in this particular variable. Then in the pointer 2, okay, and using shorthand. So shorthand is for what? It declare and assign the value. So pointer 2 declaring assign the value, and symbol fetches the memory address of this value variable, which is not storing the exact value of 42, is storing the memory address of 42. Okay. Then we are printing that. Now here I'm printing actually the main the actual value, but for example let's forget this. Okay, we'll just print the memory address first. Then in pointer 3 you can see creating a pointer with new keyword. Okay, or new, not keyword but new function. So pointer 3 then shorthand equals new function, and what is the pointer? This is the pointer for integer type. Okay, that's why int, it will create a pointer of integer type and allocate the memory as well. Okay, then in starter pointer 3 we are storing the value as 100. Now check this part very carefully. Since it's also allocating the memory of this particular pointer address, where the moment you say star pointer 3 and 100, in that particular memory is going to store the value as 100. Okay, because you're using this star symbol. Okay, or the asterisk symbol, and you're printing the value also of this pointer 3. Now I'm not printing the value of pointer 3. Let's first print the, like, instead of printing the actual value, let's print the memory address. Okay, and now pointer to pointer, which is using this. So we have pointer 4, which is the memory pointer address of using and, right? Using and, it shows the memory pointer address of pointer 3, and pointer 3 is what? Pointer 3 is also actually a memory address or pointer, right? Right. So it will fetch the memory address of another pointer, which is pointer 3. And again here I will just print the memory address, not the actual values, and then we'll modify the script and we'll print the values again. So go run pointer then declaration. Okay, see first one, And this is very important. Okay, if you define a pointer and don't assign a value, it will be nil. Okay, so default or zero value of a pointer is actually nil. Okay, then the moment you assign a value, okay, so we're declaring a value, of course, and then we are defining pointer 2, and this pointer 2 variable, we are storing the memory address of value variable. Okay, and what the memory address look like? This 0 into 14 something number, right? Now if we want to print instead of the, or if you want to get the number or original value of the variable that is pointing to, we just have to do the star, okay, or asterisk. Then in the, when you are creating a pointer with a new function, there also you see it's creating the it's storing the memory address or creating a pointer, and of course the fourth one is actually creating the pointer address of 4. Okay, now because this pointer 4, okay, is actually stored the memory address of what? Pointer 3, isn't it? But we are using star, is actually pointing to this one. If you see this matching with this, so the moment is star or asterisk is actually the value pointing to this particular exact value itself of pointer 3. If you want to see the actual value, not the original value, but the pointer at memory address value, just remove the 2 asterisk. Okay, and let's run it. Okay, you see first one is of course is nil because we didn't store any values there, no memory addresses, so it will be by default nil. In the second one, now we added the asterisk, right? That's just printing the value 42. So if you don't mention the asterisk, it will print the memory address, look like this. And if we add the asterisk, it gives the actual value, okay, which is 42. Then with the next one, we are printing the pointer 3. Now see, that is using the new function. Okay, we are having the pointer 3, which memory address look like this. Now for the pointer 4, see it's a pointer 4 is a pointer of pointer 3, but see memory address is different. Okay, now the moment you add a star, okay, and just run it, it's printing the actual value, which is same. See 08 0 into 14 and last 0 018 018. Then give another star, then it will print 100 because it's like 2 pointer, right? So pointer like asterisk, it will point to the actual value, which is 100. Now here also the top pointer 3, let's add a star, it will point the value to the original value, that is 100. Let's run it and see. Yes, 100 and 100. Now you understand how to declare pointers in different ways. Now let's learn about the common operations with pointer. First case, dereferencing a pointer. For this use case, for example, we have a variable called x, which value is integer type and value is 10, and we're creating a pointer of that, which is var p, then the asterisk in, which is the here p is a pointer or integer type pointer, okay, equals and in the sense it's fetching the memory address of x. Now to access the value of the original variable x, okay, we have to use the star operator, as I shown in the just few minutes back, right? There we use the star operator to fetch the original value, right? This is called dereferencing a pointer. Okay. Now point 2, which is changing the value at pointer. Now for example, we already have a pointer, okay, p, okay, just in the first example, right, p, that is a pointer, right? Now I want to change the x variable's value, which was 10 by the way, okay. How I can do it is I can use the dereferencing, which is star or asterisk p equals 20. It will change the x variable's value, okay, via the dereferencing itself. Now the point 3, which is comparing pointers. How can you compare the pointers? Very easy. For example, I have 2 variables, okay, were a and b, and both are the integer type. And then in the variable p1, we are storing the value of and a, which is the memory address of a. Then in the variable p2, which is the pointer variable, we are storing the value of pointer to b, which is the memory address to b, and then b. Then in pointer 3, we are storing that the using the shorthand, we are storing the value of memory address value or pointer address of A. Okay. Then how can we compare? We can use the equal. You are checking P1 equal P2 or not, P1 equal P3 or not. Okay, and it will return the true or false way. Okay. Then the fourth way is passing pointer to the function. For that reason, we have one function here which call it func, then increment, and as an input parameter we are using the variable x, and the data type is the integer type of pointer. Okay. Then what you're doing, you are increasing the x's value by 1, so x plus plus. Now again, we are actually via this pointer changing the original variable's value. Okay. Now outside the function we have var value int equals 5, which is the main variable here, which is integer type. Then we are running increment, and then the input parameter we are passing using the and sign or and symbol, we are passing the memory address or the pointer value of the value, and it's getting passed to the increment. And since via dereferencing using the asterisk, then the pointer variable x plus plus, we are incrementing the original variable's value. Okay, and then you're printing it, it will be 6, of course. Now let me show you all this in the practical hands-on way. Now the pointer example file you will find in pointer underscore common underscore operations.go file. Okay, here we have one function, that is func modify value, which is to show the function part. Now let's start with the main function. Okay, where first I'm showing you the dereferencing to a pointer example, where in the variable a we are storing the value 20, and in the pointer a variable we are storing the memory address or the pointer value of the variable a. Okay, and then you are printing the first the original value, and then the using the pointer the original value. Okay, using that dereferencing. Okay, then we are changing the value of the pointer a or ptr a variable value, and since we are changing this ptr a the variable value via the dereferencing, okay, that means it will change the value of a as well, because pointer a is, I mean, it's like pointer is the pointer of what? The pointer of a. That's why the moment you use the dereferencing using that asterisk symbol and then pass that pointer variable name equals to new value, it will change the original variable value as well. Then we are comparing the pointers. We are using b is equals to 20. B is a new integer variable. Then in the pointer b, we are storing the memory the pointer value or the memory reference value of b. Okay. Then we are printing that is it like ptr like pointer a and pointer b pointing to the same address or not. We are just checking that. Okay. And then we are storing in the p1 variable, we are storing the memory address of variable a. In p2 variable, we are like, which is a pointer variable. Then in the p3 variable, which is the pointer 3, we are storing the value of a again to check that p1 equal to p2 or not, and p1 equal to p3 or not. Okay, just to check the variables. Okay, and then finally we are here we having the a value, right? That we are using the modify that modify value function, which is what in the modify, like how we use the keyword called function to declare a function. Then the function name, which is modify value. In the input parameter, we are passing the pointer, then star in, which is the pointer that input we are accepting. Okay, and then by dereferencing, we are changing the pointer value. This is how the original variable that you are create the pointer, that value will change. Okay, so let me quickly run it and show you guys. And the example is pointer common operation go. See, it is original value is a is 20, of course. Then the dereferencing pointer gives the 20, which is why, because pointer a is the pointer of what? A, right? We get the same value. Okay. Then we are checking that after changing, say we are changing the value using the dereferencing, then we are making the pointer a to 25. Now since we are changing the value using dereferencing, that means it's changing the original variable value as well, which is why while printing a is printing what? 25. Then we are comparing, right? Now in the comparing pointer case, we are storing in the v variable the value of 20, and pointer v, we are storing the memory reference of b. Now we are checking that pointer reference a and pointer reference or pointer of b is equal or not, which is false because the values are different and memory address of course will be different of the different variables. Then we are storing the A's value in P1, B's value in P2 and A's value again in the P3, and you're comparing. Of course P1 equal to P2 is not, okay, because P2 stored the variable pointer reference of B, right? That is false. But yes, in the P1 we are storing the memory reference of A, and in the P3 we store the memory reference or the pointer reference of the A. Then in the final example where is shown the function that passing the pointer to a function, there we are changing the value by dereferencing, which is changing the original value. So since we pass the pointer A, and pointer original value was actually what, 25, right? But after you change the value again using the dereferencing with 30, that's the reason A variable value changed to 30 now. So these are the different common operations you can handle or you can do using pointers. Now let's start learning about structs. So what exactly is struct in Go? So a struct in Go is an composite data type that groups together variable under a single name, and this variable are known as fields. Now, what are the characteristics of these structs? First, data modeling. Structs are exclusively used to model real-world data and entities in applications. Second, configurations. So structs are often used to hold configuration data. Third one, design patterns. So common design patterns like decorator, adapter, compose can be implemented using struct. And in this entire course and journey, in our future session, I'll be covering that as well. Now, fourth one, fields. So struct are composed of fields or attributes, okay, and each of which has a name and a type. And I'll show you shortly, don't worry. Now, field can be any type, including other struct, slices, maps, interfaces, and of course, any other normal data type. Okay, then the fifth one is methods. So we can even define methods on struct as well. This allows structs to have behavior associated with them. Then the final one is tags. The struct field can have tags which are string literals associated with the field for metadata purposes. Okay. Now let me show you what are the different ways you can define struct in Go. First one, the basic declaration. There you just first use the type keyword, then the name of the type or custom type that you are going to create, that is a person here, then the keyword struct to make it a custom data type or a struct. Okay, and inside that you have to mention the fields. What are the fields? Because ultimately what, a struct is a collection of fields, a collection of other data types. Okay, so now type, how to define type, then space, the custom type name or struct name, that is the person here, then give space and then mention struct because it's a struct we're defining, and inside the second brackets you have to mention the fields. And what are the fields? Name, age, could be address, could be a phone number, right? And based on the data type you have to use either string or integer or maybe boolean, all those things. Okay, so this is how basically we define struct. Now the second way, which is declaring and initiating together. So for this example we have var, then the variable name person, then the custom type which is person in title case equals the person in title case, which was this. Okay, custom struct. Then what is the name field value? Alice. What is the age field value? 30. And name is string. So string is Alice and age is 30, which is integer. So this satisfies the case. Then this is one case how you can define it, or you can use a shorthand. Okay, which is more easier by the way. Which again, the variable name is person, then colon equals, which is the shorthand. Then what is the data type? Which is person. That is the custom data type. Then you are passing the value. Then just directly pass the name and comma, then the age. Okay, just one by one. So if you have three fields, then one by one, three field value. Okay. Then the third option, using the new keyword. Okay, and in pointer we cover the new keyword. Similarly here also you can create the variable using the new keyword. Okay, so person pointer colon equals, because it gives a pointer. Okay, that is colon equals just shorthand equals person. Now this way you create a pointer to the person struct. Okay, and then to add a value you can say person pointer dot name is what, Bob, and person pointer dot age is 25. So this is also a way you can create struct pointer. Okay, then the fourth one is the anonymous struct. Okay, so it's a one of use case for like just one time you want to declare and use it for those cases. Okay, and how you do it here, for example, use the word person equals, there itself we say struct, we use the struct keyword. There we define the structure, which is name and age. So name is string integer, and immediately after that there we mention name value and age value. Again, you are not creating a custom struct here. I mean, you are creating, but you are not creating a separate custom struct. You cannot reuse it. It's just for this and this variable only. Okay. Then the fifth one, nested structs. Okay, for this example, for example, we have first struct that type address, which is the custom data type is address, and struct, what is this struct we are giving, city state, and for both we are giving the data as string. Okay, and now we are creating another custom struct or custom type of struct, which is type person, and of course after the type person you have to use space and say struct, mention name, of course a string, age which is integer, addition part. Additionally we are saying address. Now you can just skip giving the address part also, it will become a embedded field, just like we were doing in the sixth point. So embedded and anonymous fields. Here we are first defining first struct, that is type space the struct name or custom data type name is contact, then space struct, then inside the second brackets we mention phone and email, and both are string data type. Then after that we are creating another custom data type of struct, that is type, then space person space struct. Inside the second brackets we mention name, age, but notice that in previously nested struct we are giving address space address. We can skip that. Okay, you can just say the custom struct only, or the main struct only, which is contact. We don't have to pass on the custom data type. Okay, it will automatically detect it. Okay, this is called embedding. So these are the different ways you can declare struct in Go. And now let me show you practically how to work with it, or how to declare it practically. Okay, let me show you. The struct declaration you will find in the file called struct underscore declaration.go file, and there we are first defining our very first basic struct, which is type. We use the type keyword to define the custom struct, and the name of the struct is person, or name of the custom data type is person. Then give the struct keyword, and after that giving space, mention the second bracket opening and closing. Inside that mention what are the field you want in this custom data type or custom struct. Now there you just mention name, because it's the person you're talking, right? So person have name, person have age, person have address, person can have mobile number, like so and so, right? Now the second one we are declaring and initiating the together. So here the variable name is John, then colon equals, what is the data type? Person here, right? And person of which field? Name field and age field. Name field value is John and age field value is 30. Okay, and then using the new keyword, which is we're getting pointer. So Jane, right? Jane colon equals a new keyword, a new function, not keyword, function. Then in that we passing this person struct, and then we are passing say Jane.name and Jane.age. Okay, and you can use that way. Now again remember, this is a pointer. If you want to print the actual values, you have to use this star. Okay, then the anonymous struct, where you're using a variable name called anon, then colon equal shorthand equals, again it's a one time only, the struct, and then you define the structure, and in the same line or in the same declaration itself given the values in next opening closing or second bracket, which is country USA, and code is 1. Okay, then in the nested struct, here you're defining new struct, that is type, then space address, and again space the struct keyword, Inside that, you mention that what are the fields, which is city and state. Then we are creating another struct, that is type, the type keyword to declare a struct. Then name of the struct, which is employee. Then give space, then struct to make it a struct. And then just mention the next thing, that is personal info, which is pointing to the person struct. Okay, that is defined here. And then the address, we just define address here, right? So this is how you can create the nested struct. Okay, then when adding the value, we are using emp colon equals employee, which is the final struct. And there you are passing in personal info, you are passing, we are giving the value, that is person, then name, Alice, age 28. Okay, in the address you are passing address, then address have what, city and state, right? So city New York and state New York. Okay, NY, state NY. Then the embedded example, we are creating one custom struct, that is type manager and struct. And of course you know the syntax by now. Inside that, the first field is person. Okay, and the second field is department. And see, we are not giving the space and then the data type, because if you just mention the custom struct, it will automatically do the type of internal fields. Okay, now here additionally as a field we are seeing department, that's the string. Now when creating this mgr variable, manager variable, from for this custom data type struct manager, you have to use mgr colon equals, then what, the final custom data type struct. Then inside that you have to pass, first parameter was person, right? So person colon equals, then the person, and then the name and the age. Okay, then what was the department, is string. Okay, that is finance. Okay, and these are the ways you can define the struct. Now let me just quickly run it, it will become more clear. So clear, then go run struct declaration. Okay, and run it. See, the very first, when you just define it, we didn't printed it. After you given the value, so declare and initiate together, that is John 30. Okay, that's like how we passed. Second one, using the new keyword. Okay, new keyword, we first create the pointer struct or struct pointer. Then in that we pass the name and age. Then to print the value of actual this Jane variable, we have to use the asterisk symbol. Okay, then for the anonymous struct, we didn't mention the person or anything like that, right? We just define a custom struct here using the struct keyword, and we pass the value in the same way. Okay, just in the same definition itself. Then it's printed USA 1. After that, for the nested struct, we defined address and employee. In the address, we have city and state. In the employee, we are saying the personal info, this type is person, address, and the data type is what, address. But we can skip, if the name is same, we can skip it. That is in the next one, that is embedded. And you can see the print also, the nested stack example, we are giving the Alice 28 and New York NY. Okay, because the personal info, we have Alice 28, that is the name Alice, and age 28. For the address, we have New York, that is the what, city, and the state New York. So we just have it there. Now in the embedded one, see, we are using type manager struct, it's a custom data type. There you are not, after person, you are not specifying the in another person. So person custom data type is should be person, right? Or maybe person data, it can be anything. Then you have to mention, if you don't mention this, it will error out. But if you just say exact same word or exact same as struct, then it will auto detect, okay, this is a struct. Okay, and that's how you can say person, then you pass the data as person and pass on the say name and age like this. For department, it is a string we have mentioned here, so department finance. So these are the ways you can run. And you can see in the embedded field, we have the Bob 35 that you have passed here. Okay, and the department is finance, so financier. So these are the different ways we can declare struct in Go. Now let's learn about what are the common operation we can do with struct. First one, creating an instance of struct. Okay, so It is actually very easy. We have already done it. Just now also I'll repeat. So we first define a custom data type, a struct. There is type, then space, then that struct name or the custom data type name, that is person, then gives a space, and of course the struct keyword to make the struct. Then opening closing of the second brackets and mention the fields. Then we use the variable p colon equals the custom data type, which is the person. Then in the name we give Alice, in the age we pass 30. Okay, so this is how we create the instance of the struct. Now how to access and modify the field? If I want to get the value of any particular field, we have to first we have to access the value via the variable that you have created, which is an instance of struct, that is p here, right? Now to access p fields, internal fields like the name or age, how can you do that? To do that, we have to use the variable name, that is p here, right? P, then dot, then what is the field name, right? It can be age, it can be address, anything. So that particular field name. So first the variable name dot, then the field name. Okay, for example, p dot name. Then how to assign a value or update the value? Same way, p dot the field name, for example age, equals the new value 31, and these are the way you can access and modify the values. Then the point 3, that is the pointer to struct. How can I do that? Again, very easy. Just the variable name, for example p here colon equals, then AND operator. You know AND operator, why use it? We use the AND operator to fetch the memory address of a variable, right? Now here we are defining the variable, and of course we are dynamically fetching the memory address as well. Okay, so p colon equals AND operator, then the custom data, which is the person, then you passing the fields. The name field value is the Carol, age field value is 28. Okay, then the point 4, that is the method on struct. So it's not just a field, but you can add function or method to the struct as well. Okay, so how can I do that? You can just say func, the function, like function keyword. Then importantly, in opening closing of the first bracket, mention the variable name, that is p, and space, then person. Okay, then after that space and give the function or method name. So that is greet. Here in the greet function, we are not accepting any input field, but if you want, we can get it. Then what is the return type? Is string. So here return hello, then my name is, then plus p dot name, because in the p we have the struct variable fields, right? So p dot name. Now the fifth one is tagging the struct field is very important. Let's see the example first here. That is type, then space, person. This is a custom data type name. Then space struct, which is the keyword here. Then opening closing of the second brackets, we mentioned the field name, that is name. Then string. Now in the JSON, we are saying the name is name. Okay, in small, all small. In the age is integer, but in JSON metadata we are saying it's age, all in small. Okay, so we can tag struct field with additional metadata, often used with encoding decoding of different libraries. Okay, and while we explore through our learning journey of this Go, we'll be encountering that and we'll be learning that as well. Okay, now let me show in code how you do it. It will become more clear, right? The common struct example find in struct underscore common underscore operations.go file. Let's understand this file first. Let's start from the beginning. So package main, just to mark as a main package, then we're importing fmt for log printing purpose in the CLI and reflect. I will tell you the reason after a little bit later. First, we are defining the structure. Okay, that is person struct definition. Type space, then person, which is the custom data type, then space the struct. Okay, and what are the fields? Name field, which is data type is string, age field, which is the integer data type. Okay, then we are creating the function, that is method on person struct, which is func, the keyword, then p, then person. Again, person is what? The pointer. Okay, then say hello. So it will print, say my name is person s and I am the person d8 old. Okay, here you just how you are getting the values, p dot name and p dot age. Okay, now this is by reference we are creating the methods and it automatically attached with the custom struct person here. Okay, then we are creating another custom struct here, which is type employee struct, and here we are adding the tags. So it's of course id is integer and name is string, but in JSON we are saying id is smaller and name is smaller. Okay, now in the main function if you come, we are from the main struct, the very basic struct, we are creating one variable Alice, then colon equals, it is a custom. What is the data type of this Alice variable? Person. And what are the fields or values, field values? That is field name value is Alice and age is 30. Then you are printing the struct. Okay, then we are accessing the value and modifying field. Now if I want to access the Alice name, how I can do it? I can say Alice dot name. So Alice is the variable, dot name is the field name. And if I want to change the Alice to some other value like Alice Smith, then Alice dot name is equal to Alice Smith, and that will modify the name field, and we are printing after that also. Now pointer to struct. Okay, so first we are defining one variable Bob colon equals, then the and symbol, then the customer type person, then of course the field in the second bracket, inside that you mention the name Bob, age 25, and that create a pointer of the struct, okay, in the Bob, and we can then print the Bob. Then after that, because this custom struct, we have attached one method, right, or function, which is say hello, and how you are attaching with this person, this portion of the code is responsible for that, where you're saying p then asterisk person. This is how the linking is happening. Okay, now we're coming, since the method is linked with the custom struct, we can call it, so Alice dot say hello, Bob dot say hello. Okay, like opening closing of the first bracket to execute the function. Now for the tagging struct field, how to do it? So we'll use the emp variable colon equals shorthand employee, and employee defined on top here, right? Employee, then custom type, that is employee, and the fielder id and name. Okay, go down. Now emp colon equal employee, you're passing id value as 1, the name value as John Doe, right? Then we're using t stand for tag, and t colon equals reflect dot type of emp. So we are passing that emp with the inside the reflect type of function. Then in the field, then in the next line we have field underscore, and colon equals t dot field by name. So this is how you can fetch the tag name value by the name of the field, which is field by name, and then we're giving the field name here. Okay, that is field name. Then you're printing the how you're printing it. So field dot tag dot get, then what you have defined here. So field name, then tag is what, JSON, it will return the name. So field dot tag dot get, it will print the whatever JSON value you have mentioned there. So now let's run it and it will become more clear, of course. So go run struct common operations. So here let's come by the value. First we printed the struct instance, which is here we are defining the structure, and here you are initiating it, okay, or creating the instance in Alice. So Alice 30, the value you have passed here. Then we have more, first we have printed name before Alice. This is how we access the value using Alice dot name, using dot we can access the value. Then we change the value using Alice dot name, again using dot, then the field name equals, it assigning a new value, which is Alice Smith. Then in the pointer, see in the pointer Bob colon equal, we have created the using AND operator, we're getting the pointer of person, and then you assign the value in the same line, which is name Bob and age25. See here Bob, we have the AND sign, which is the meaning of its pointer. Okay, if I want to just print the value and not the pointer, just run it. See, its pointer is Bob, that AND sign is not coming anymore. Okay, because we use the value pointing. Okay, now the next one is the methods. See, we have Alice dot say hello and Bob, because it derived this method from the person, and person is mentioned in this first parameter as p star, which is the pointer person. This is how it's getting linked with the this custom struct. Okay, and while you print, it's a my name is person and I am person D role. So that string is coming for the name, and the that digit I'm person D is coming for the age number. Okay, which is what we are seeing here. The moment you are calling Alice.say hello and Bob.say hello, it's printing hello, my name is Alice Smith and I'm 30-year-old. And for the Bob, it's saying my name is Bob and I am 25 years old. Okay. Then in the tagging part, you see we printed what? We printed the by name, get field by name, the name, and that fields JSON value, okay, or JSON tag value. So if you see the JSON tag value is name, so tag on field name is the name in smaller case. So these are the different ways you can use struct. Of course, there is a lot more to learn and we will learn as we move forward. Now let's go deep dive into interfaces. Now what exactly is an interface in Go? So an interface is defined as a set of method signatures. A method signatures include its name, its parameters and return types. Okay. Now what are the characteristics of these Go interfaces? First, type agnostic. So interfaces are not tied to any specific type, and any type that implements all the methods in the interface is said to satisfy the interface. Okay. Second one is the implicit implementation. So unlike many other languages, Go does not require a type to explicitly declare that it implements an interface. Okay. If the type has necessary methods, it automatically satisfies the interface. Okay. Then the third one is the runtime polymorphism. So interfaces enables polymorphism in Go, and a single interface can be used to represent different types as long as they're implemented in the interface methods. And I'll explain all these things, I'll show all these things, don't worry. And the fourth one, the interfaces help in decoupling the code by not depending on the concrete implementation, but rather on the behavior or based on methods. Okay. And the final one, empty interface. Okay. And this empty interface can hold any type of value, as every type implement at least 0 methods. Okay. It's commonly used for function that can accept any type of value. Now let's understand the different ways to declare interfaces in Go. First way, single method interfaces, which is just type, then the interface name, that is for example a reader here, then the keyword interface, and then in the second bracket just mention one method. For example, read, we can use this read method to read the bytes. Okay. Then the second method is embedding interfaces, just like we embedded the structs, similar way. Okay. So for example here we have the type writer. Now the writer is the name of the interface, then space, then interface keyword, and inside the second brackets mention the write method. Okay. Now after that is what the most important part, that is the type, then space, read writer, then space interface. So in this interface, the read writer interface, we are embedding what? Writer and reader. And by deriving writer and reader, we are also getting all the methods of reader and writer as well. Okay. Now the fifth one, which is empty interface. Now type any, then space interface, which is an empty interface, specifies 0 methods and is satisfied by any data type. Okay, similar to object in Java or interface in C#. Okay. Then the fourth way, that is interface with multiple methods. For example, type space shape, then space interface to make it an interface. Then inside second brackets we mentioned area, and the data type, that is export will be, or return will be there. Then the parameter function, when space, then the return type. Okay. Then the fifth, which is functional interface or single method interface. Now let's go with the example first. Here type, the type keyword, then space, the interface name, then the space interface keyword. Then inside second brackets we have a sample method called serve HTTP with as a parameter is expecting W, then the data type is HTTP response writer, and R is the pointer for HTTP response. Okay. Now an interface with only one method is often used in Go, especially for callback function and implementing functional options. Now don't have to stress out right now. As we move forward to different differentiations, we'll go to very details of all this. Okay. The sixth one, which is interface as a constraint, and it is also called generics. Okay. Now let's go with the example first. Here type space number space interface, and inside the second brackets we mention int 64 or float 64. Now what it is? Now we know that in Go there is default integer type. Now for example we want as a custom kind of data type. We can do it in different ways, but just as a single data type, okay, we can use interface, which is very simple, right? So type space number. So instead of suppose places where you just want to use a type as a number, you can use that way, okay? So type space number space interface, inside second bracket you mention what is the return type, which is integer int 64 or float 64, okay? With the introduction of generics in Go 1.18, interfaces can be used as a type constraint in a generic function or types. That is very interesting thing, and as we move forward we'll be exploring that also a lot. Okay, now enough talk, let me quickly show you how to declare this interfaces different ways in practical way in codes. Now let me show you the code. The code for interface declaration is interface underscore declaration.go file, and there we'll let's go line by line. Okay, the first point is a single method interface. Okay, and there we have type then space speaker. The interface name is speaker. Okay, and in that we have a method is deriving from speak, this one. Okay, but we're defining one struct here, which is type doc struct, and we have the field name. Let's go down and say embedding interfaces. Okay, so we have the type animal, then interface. We are saying speaker. Speaker is what? Speaker we get from the original interface. Okay, so speaker, and then you see that we have move, and there is a new function move. Okay, and that move function is what we are getting from the down. Yeah, this one move function. Now let's go for the next one, the type the empty interface. Okay, third type, and we're just printing anything. You can just print anything. V interface, the empty interface, and then you're printing what we're getting in the interface. Okay, then interface with multiple method. So for example, we have a custom interface, that is the vehicle interface. So vehicle is the name of the interface. We have two methods, start and stop, and we have the struct here, which is then we are naming this car struct. Okay, then what is the method receiver? This is the method receiver, and how this interface and what is this function deriving from? Because start we are mentioning the method here, right? So it's method getting derived. Then we are saying car started or car stop based on the function name, and then let's the sixth. Okay, the fifth one was the functional interface, but it's exactly same as single method interface. Okay, so same example will work here. Then the sixth one is that interface as a constraint. Okay, or generics. What is that we're doing here? Func describe t as now t speaker. Okay, so the type is speaker and the variable type becoming t. So speaker is what? This one, right? And we are creating the type here, custom type t, and then as an input parameter we are expecting t. Then in that now we are saying then what is the data type t, and what we are printing t dot speak. Okay, and then we have the main method. Okay, where we are doing all this, or we are running all the code there. Now let me quickly run, and again after getting the result let me explain a bit more. Okay, so go run and interface dot declaration. Oh, okay. So see, first one, the body says woof. So body is what? Body, for example, the dog speak, right? And that function was where that's derived from the dog and interface the speaker. So if you go down here, yes, this is a body says woof, and for the bird.speak function, that was actually the method derived received from the bird, and it was a speak function, right? So that's we have printed here. Similarly, the bird.move, because in that bird we have receiver method receiver here and the move. Okay, that's why it printed the bird flies, right, or 2D flies. Then in print anything, an empty interface can hold anything, right? That's why an empty interface can hold anything. It printed 42 because it can expect anything. Then we have the car dot start and car dot stop, where we had the Tesla car started and Tesla car stop. Now look at it very carefully. This describe function. Now this describe function, okay? If you see this describe function, this part, okay? This particular T speaker, what that means? This means that this is the type parameter list. We are saying T, then what is the type? Speaker. And it's also saying that T is the type parameter that is constrained by the speaker interface. This means T can be any type that implement speaker, okay? Then it is coming for the interface part, right? And then in the function parameter, where it's saying T and then space the capital T. What is that? This is making sure that the function takes a parameter T of what type? The type is T, the capital T, which is what? The speaker interface, okay? And then the function, what you see, we have called the T.speak and the result is printed, of course. So this is why when it's dog or it's bird, both the method, I mean for both the say data type, the interface is derived from the speaker interface. You see the dog here, the interface is what? Speaker. And for animal, interface what? Speaker. So both cases, the interface is what? Speaker. That is the reason where you are saying or you're using this constraint or generics, it's supporting both. But what if we supply the car here? Okay, say describe, say car. It will throw error because of course it doesn't have the method. So it will simply error out. Okay, because say T type car does not satisfy speaker. Okay, or missing the method speak. Both are the reason. Okay, so there is a reason. First of all, it does not satisfy speaker and also missing the speak function. That is the reason it will not work. It will only work for dog and bird because it's deriving from what? The speaker. And that is the reason. So these are the different ways you can declare the interface. Okay. Now let's learn about the common operation that you can perform or do with the interface. First here we're declaring the interface where we have the type, shape and then space interface, which is making the interface. Now it's just two methods. Okay, in the second, what you're doing, we are first creating a stack, okay, which is a rectangle stack width and height is expecting. Then we have two functions because remember in the area and parameter, the two functions you have defined inside that particular custom interface. So we are defining that function here, and in the function as a type expectation, we are expecting or type declaration, we are declaring R, the data type is rectangle, and for that is for area, and for perimeter also the type declaration R rectangular. What is doing? So a type implements an interface by implementing all the methods declared in the interface. Okay, how it works I will show you in the code directly. Then in the third one, the type assertions. So let's look at it. We have declared a variable. So for S, the data type is what? The shape, and equals rectangular. Now rectangle what? Rectangle is the stack that you define here. What is the input? It is expecting width and height, and we have given width and height. Now since we make sure that the with interface is interface, I mean it's implementing what? A rectangle and all the functions as well. So we are first running R, then comma OK, then the shorthand equals R, then in the function parameter saying rectangle. Okay, if it's okay, then we are printing the rectangle width. Why? So this type assertions are used to retrieve the dynamic value of an interface, and this is useful when you need to access the specific type and its methods or properties to make sure all that exist or not. Okay, I will show you in the code, don't worry. Now let's go to the fourth and final one, which is interface with type switches. Okay, now type switches are a way to handle different types of data stored in interfaces. An example here. So here we have function do, and it's implement as a data type in the parameter respecting I interface, and it can be any interface, okay, or any data type. Then in the switch case, we are saying v colon equals the shorthand is saying I dot type. So the data we receive as an input in the interface. Interface can or say in interface and opening closing of the second brackets can hold any data type. Okay. Now it's saying case int, if the type that you are assessing, okay, is integer, it will print integer. If the data input, the data type is a string, then it will print string. If the value is like checking, it's the say unknown type, it will say unknown type. Okay. And while in the example that I'm going to show you right now, you will see, you will understand this very carefully. Let me show you the code. Interfaces common example, you will find the file called interface underscore common underscore operations.co. Then let's understand the code first. First, we are creating an interface called type and space greeter. The interface name is the greeter, and it implements one method called greet. Then we have a custom data type or struct. We are saying is person, so type person, and it have field name. Then how we are deriving it? So in the function greet, okay, this is that part of this interface, right? As a method. There we are saying the type declaration we have person. So and by doing that, this become of like it kind of getting derived from this particular interface by type declaration. Okay. So in the type declaration p person, we are saying the function name is greet, and what is the return data type is string, and it's saying hello, then p dot name. Then in the type assertion example, we have print details where it's saying that again empty interface can accept any data type, so it's expecting that, and checking if the data type is string, then I will print string. If it's not string, it's string. Let's say give another example with a similar kind of concept where I'm checking the type and saying either switch cases, the example that you have seen in the main slide. There I'm just printing is integer, or this case is string, then I'm printing string. If the case is like not matching, then it's the unknown type. Okay. Okay. So in the main code, I'm giving an example of how to implement an interface. Okay. First, we're defining a struct. Okay. Because if you see, we have this person struct, that data type is getting used here, right? So you're first defining one struct person, and person struct, what the person struct expecting a name, right? So the name of the struct is Alice. The name of the person is Alice. Then we are going to create an instance or implement the interface. Okay. So var greeter, what is the data type? Is this interface. Okay. What is this one? This interface greet. So var greeter, then space in title case greeter, which implement the interface, equals person. Okay. So now this greeter is what? Say instance of interface, or we are implementing an interface where it have the data, which is what? The person, because after getting the struct only we can run on this code, right? So that's the reason. If you go down, we are saying greeter dot greet. So this person, after getting into the greeter, will have to we can call the greet particular function, and what greet function doing what? It's saying hello, then p dot name, right? So it will say Alice. So it will say hello Alice. Okay. And then we are going to do type assertions. How to do that? We can say print details supplying hello. It will print string. For example, we give number. It will print what? It will say it's not a string. Then type interface with type switches, because that I've just given an example in the main slide where we are saying we are supplying the describe function hello. It's a string. We are giving 2023. It will say integer. And suppose we give the 3.14, it will say unknown type, because we are either saying that integer or string, but we are not handling the float type. Okay. Now let me quickly run the code and it will become more clear. So go run, then interface declaration common operations. See, first here say hello Alice, because we say greet, and how we do that? In while creating, or so while implementing interface, we have to give the we have to supply the value of the struct, that is person, and then when you call this, say the greeter, okay, so this greeter in smaller case dot greet, so it already have the struct, it already have the method in it, so it's simply calling the method greet, and it's saying the hello Alice. Now, in the type assertion, in the first we supplied what? String. It say it's a string hello. Then in 42, it was not a string. So it will come to the else part. It will say it's not a string. And which is happened. It's saying not a string. Then in the interface switch cases, we have supplied what? First, hello world, which is a string. So it checked that code in the interface here, and a describe function. Then inside is checking, is it the case is what? The string, which is I, the data that you have supplied, dot the type, and we're checking, okay, it's a string. In the next one, we supplied what? A number or integer. Is also check that. So is it case integer? It's saying yes, it's the integer, then the value. Then in the default case, which is in case no case matches, which is 3.14, which is the float type, right? And since we have not handled the case for float type, it's saying unknown type, which is why it printed the unknown type. Now, interface is actually very vast and there's a lot to learn. At the beginning, it might even seem very confusing, but the moment you keep practicing and keep doing the code, as we do in our through the different session, it will slowly become a more easier, okay, to grasp and try it out. Okay, so don't worry. We have covered the common representation for interface, but in our future session, we're going to explore a lot more about these interfaces. So don't worry about that. Okay. Now let's learn about how to handle errors in Go. Unlike many other modern programming languages that uses exception for error handling, Go uses a different approach that relies on returning error values. Okay. Let's understand about the error type. So Go has a built-in interface named error. So Go has a built-in interface named error. It is a simple interface with a single method, error string. Okay. Now error is the method and return type is string. An error variable represents any value that can describe itself as a string. Okay. Now returning errors. So function can fail, return an error value as the last return value. If a function succeeds, then error is nil, otherwise it's a non-nil. Okay, this is the concept here. Now let me show you the different ways you can return errors. First, the return error, okay, normal. Okay, for example, we have a function that is divide. Okay, and as an input parameter it has what? A and B, which is the float 64, and it return, the return type is float 64 or error. Okay, two things, float 64 the result value, comma error. Okay, if any error, you have to pass the error value. Then for example, A is the one that is get divided by B, right? And if B is 0, then it's a problem, it's a division by 0. So if B equals 0, we must return a error, right? So that's why we're return 0, or you can see null also. So return 0, then comma error dot new. So errors dot new. Then in the first bracket, you have to mention what is the reason, what is the error reason, right? So they are saying it's a divide by 0, which is not possible. And if there is no problem, then in the return, it will be return A by B and comma error as nil. So that means no error, right? In the second way, we are checking error. So in the first, you understand how to return error. In the second, we have to checking how to check for errors. So there, just this divide function that we have defined, we're going to use that. So result, comma err, colon equals, that is a shorthand. We are calling a function that is divide. In that, in the first parameter, we are supplying one integer value 10, and in the second one, comma, we are supplying the second parameter 0, which is, it's going to be throw error, right? So if error happens, that means in the error variable, we are going to get the error, right? So if error not equals nil, if it's not nil, then it is going to run the code, that is in the code block format. It will just print error, the error reason it will print and return. So it will stop the execution there. If there is no error, then it will continue executing and it will say result is the maybe 10 by whatever the number you supply, that one. Okay. Then third one is the custom error type. We learned about the interfaces, right? So we can keep extending, keep doing the polymorphism, right? So similar way, we can define our custom error methods or custom error codes. Okay. For that, we define called type and space my error space struct, and there we are first giving the MSG, the message, as a string and code as integer, and then in the function we are supplying as a type definition e space the pointer of my error, then space error, and the string we are saying that return, then we're just printing the error, okay, with the code and message. Now this is what it is. So we can define custom error type by implementing the error interface. This is useful for providing more context or handling specific kind of errors in different way. Okay. Then the fourth use case was the panic and recover. Okay, what is the panic? So panic is an inbuilt function that stops the ordinary flow of control and begins panicking or giving errors. Okay, recover is a built-in function that regains control over the panicking, so it will stop the panic. Okay, now we use the panic and recover sparingly. They are more keen to exception but are generally used to unrecoverable error in bugs. Okay, and how to use this one? For example, we have that function, risky function, just give the name there. Okay, and inside that we have a defer function. So defer func, then there is saying if r colon equals recover and r not equal nil, then we are saying recovering from r. So it's saying it's recovered. Okay, and it's an anonymous defer function. Okay, then in the panic we're saying we're running the panic function, saying something gone bad. Okay, something bad happened. The moment we say panic, something bad happened, it will come to like recover will do kind of, will cache that one and keep continuing the code execution. Okay, this is the main part. Now enough talk, let me show you the code. It will become much more clear after that. Now let me show you the code examples where we are handling errors. Okay, so in this code, okay, error handle, okay, the file name is error_handling.go file. There you will see first one is the custom. I'm defining the custom error, which is type custom error struct, and in that we have field message field. Then we are like implementing a function called error, implements the error interface for custom error. So func, then the type declaration we are saying e as custom error, pointer to custom error by the way, and the function name is error. It handling a string, I mean it's returning a string. Okay, then returning e.message. Okay, then inside now e.message is what? E is the this custom error interface, the error interface. So e.message, so message it will return. Then we have some function returning a custom error. So we have declared another function, some function flag bool, which is just to kind of make a situation to create the error. Okay, then or simulate the error. Okay, then input parameter flag bool, and it is returning the error type. Okay, so error, and then if the flag is true, then it will return the error, otherwise it will not return the error. Okay. Then we have save function, which demonstrate using of panic and recover. Okay, now inside this save function we have this defer function, also anonymous function. We are running if r equals, I mean colon equals recover, so it's running the recover and getting the result in the r. If r not equal, so it means success, then it's saying recover from panic. And after this defer function, first you are running this. Okay, so first it will panic, and r this recover function will automatically recover from panic. Then we have this divide example that I've explained in the slides. Saying in the function divide or func divide, the input parameters are a, b, and the data type is float 64. Then the return type is what? Two return. Okay, two return data types. First is the float 64 if it's success, and then is the error if it's the error. Okay, now inside the function you are checking b, if b is equal to 0, that means the divided is 0, which is wrong, it should not be. In that case we are throwing the error, saying that division by 0 is not possible, right? Now in the main function we are first giving example of the divide, that simple one. Okay, simple error return. If this function succeeds, okay, then in the result we will have value and error will be nil. If this function gives us error, if error not equal nil, that means of course there is an error, and print the error message or error value, error string. If there is no error, then simply run the or print the result. Okay, now that is the wrong case where dividing by 0 it will throw error. And the second one, I'm just show that supply some good value and it will not go to this error, instead it will just simply return the result. Okay, in the second one I'm just running some function, for example checking and handling error with custom errors type. Okay, so and there I'm supplying false, so like show them like false, then it will return some error. Okay, saying that error not equal nil, because in the return will going to send some error, then it will print the error. Okay, and in the sum save function is the example where we cover the panic and recover. Now let me quickly run it and it will become clear. Okay, so go run, then error handling.go. See the first one we are running, we're giving like we're going to divide 10 by 0. Okay, so that is why when it's come to this b is equal to 0, return 0. So the return result value becomes 0. You can even give nil also. It's up to you. But again, make sure that whatever you're returning that matches with the return type. If it's something different, then we'll throw error also. Okay, so if b is equal to 0, you can do 0 to simplify it. So if b is equal to 0, then return 0. And in the error, it will be not nil, but the what? The division by 0 error. Okay. If b is not equal to 0, then simply return a by b, and in the particular error, simply say nil. Okay. Then in the and we have seen that here error division by 0 we are getting here. Then in the second one, I have not given the any 0, right? So it will not match this error condition, and will simply return the result properly, right? Which is result 5. Then in the another example where I am trying to simulate the error case, custom error. Okay, where custom is what? We're returning this custom error, saying that we've defined the error custom error here. So using the type custom error struct and then the message that is returning. Then in the function, the type declaration, we are saying the custom error. E represents the pointer to custom error, and we are returning the e message. Then in the sum function, we have demonstrated that how this simulated the error returning. Okay, custom error returning. In the same function, you see after getting the error part here, and we're checking if error not equals nil. It's showing the error. There is a reason error custom error occurred that you are getting it, because we are simulating the function there. Okay, or simulating the error there. Then in the same safe function, you see first. Let's come here. Yeah, save function. What happened? Okay, we have this one. Okay, which we're saying up like recover from panic, and then a problem occurred. Why? Okay. For example, we do comment this one. Okay, you see, it's going to give error. Okay, so it was the save function. We panicked. Panic happened. Okay, and it's giving the memory address and all that. Okay, where the panic happened. If we have this code to recover from panic, okay, even if the panic occurred, it's gonna recover from the situation. That's why this panic and recovery is very useful when you're not sure that any error can happen. So the stacking part, error tracking, when it's happening, from where it's happening, you can use this one. Okay, panic and recover. So this is how you can handle errors in Go, and of course, this is not limited to this. A lot to learn, and we'll of course explore all that. Now let's learn about the concurrency with Go routine and channel. Now, why? So how to handle concurrency in Go? So concurrency is handled primarily through two key features called Go routine and channels. Now, understanding this concept is crucial for writing efficient and effective programs in Go program where you need the concurrency, right? This is a primary feature. Okay. So what exactly is Go routines? A Go routine is a lightweight thread managed by the Go runtime, and Go routines are used to perform the concurrent task within the Go program, and they are more efficient than traditional threads in terms of memory and setup time, making them suitable for handling high concurrency tasks. Now, how to create a Go routine? You see, for example, this function. So go then your function, and this creates a Go routine. You can simply use the Go keyword followed by a function call. This will start a new Go routine that will execute my function or any function that you define concurrent with the rest of the program. Okay, so it will not wait for this function to complete. The code will go and move on. Okay, what are the features of this Go routine? Independence. Each Go routine run independently. Non-blocking. The Go statement itself is non-blocking. The program will not wait for the Go routine to complete. Then shared memory. Go routine within the same process share the same memory space. So care must be taken to synchronize access to share variables. Now the channels. Now what are the channels? So channels are conduits through which Go routines communicate with each other. They allow the safe passing of data between Go routines, ensuring that the only one Go routine access a particular piece of data at a time. How to create it, or how to create a channel for create a channel? For that, first let's create a variable. So ch colon equals shorthand equal to make. We're using the make function. Okay. Then inside the make function as the parameter supplied chan, chan keyword chan and space integer. Okay. So that means we're creating a channel for passing integers. Okay. Now how to send and receive data from channels? See, for sending we say ch then this particular symbol, and we send V to channel CH, okay, and receiving, then V colon equals, then this symbol, then CH, receive the data from CH and assign to V, okay. And what are the features of these Go routines? Synchronization. So sending and receiving operation on a channel are blocking by default, and thus this sends operations block until another Go routine reads from the channel and vice versa. The second feature is buffering. So channel can be buffered, and a buffered channel has the capacity and does not block until the buffer is full for sends or empty for receives, okay. Then directional. The channel can be directional, either send only or receive only, and enhancing the type safety. Now let me show you a quick example for this one. In this example code that you see here, in this example, print count is a function that runs in a Go routine and communicates with the main function via the channels, okay. And the main function waits and processes messages from the channel until it's closed, okay. Let me show you practically in the code itself. The basic concurrency example you will find in basic underscore concurrency underscore example.go file. In this file, of course, the function that we talked about, the print counts, in the input parameters, we are getting label as string, count as integer, because the count you get will be running loop for that much time, and channels, that is chan integer, okay. So main channel will receive via the this parameter channel, okay. Then in the main function, okay. One thing. So in the loops, what we're doing, we're running the loop 5 times, and in the channel, we are submitting the value one by one, okay. And once it's all complete, we are closing the channel. And the moment this channel closes, okay, and the value processing also done, then only this function will exit, okay. That is the important part here. Now let me quickly run the code, and then only I think it will become more clear to you guys what's happening behind the scene. So go run, then basic concurrency example, and see what happening. So what is happening here in this example, as I explained, the print count is a function that runs in a Go routine as we supplied there, and communicate with the main function via the channel. So via this channel only it's communicating, okay. And the main function wait and processes the messages from the channel until it's closed, and then when the channel is closed, then only it print, like it's keep printing, but then only it will stop the main process, because main is running. So main, we say we go print count, we run the Go routine, and if there is a loop which run through 5 times, and suppose thing running concurrently, right? But it's waiting till if the channel is closing or not. Once the channel close and is done processing printing the values, for example, first Go routine is what? So Go routine is go to this one, then in the main channel we submitted what? 0, right? 0, and then in the main it's communicating via the channels, right? So main channel range, it's looping through and getting the value as what? Main receives 0. Then the second time the loop run in the channel, what we had? 1, right? Then in the channel we receive say Go routine 1. Similar way, keep receiving data, and once all the data process comes, the channel is closed, is closing the main code also, okay. This is how the channel communicate with the Go routines, okay. And I hope by now you understand, you have a basic idea, and don't worry, we'll go through a very in depth in our upcoming session. So yes, that is it guys for today's session. I know it's a very long one, and you stayed till long, which is the most important part, and I wanted to make you understand all the topics, all the concept very clearly, okay. So yes, if you like this session, please do like this video, subscribe my channel, share this video with as many people possible, share the knowledge, okay. That's the most important part here. And yes, let's see you guys next week with like this kind of session. By the way, if you guys already know, is good, but if you don't know, all the codes example will be in our main repo, which is what? This particular one, okay. And there you see the day 3 codes will find in this particular day 3. I was just going to push it, and after say the next day session will be what? I think this is going to be good, more interesting. In the day 4 we have GoLang or scripting and automation. We'll be writing a lot of basic scripts in Go. Then we'll automate the routine Go task via the Go scripting. We'll interact with the file system, and then the command line argument flag portion also I will show. It's going to be interesting. Keep following, keep learning, and we'll see you guys in our next day 4 session. Bye bye.